Hey, home for super mathematicians. Blessings. Um, I sound tired. Madness, madness. What wrong with you about there, boy? What wrong with you? Me tired? Nah, boy. I see vibes, man, you know. I see vibes, man. We don't know about no tired. And what you talking about? What are you on about, bro? Logs in, sir. We go look at logs on another night. Tonight I gonna do differentiation. That's what people want to do. Until they want to do differentiation or they want to do something different.
No. Let's do differentiation. That long
It was
process.
differentiation and integration, sir.
All right, no problem. I'm not
So
gonna
we are
lie.
so we are class tomorrow for bad maths.
No. I sent a message. I sent a message on the group chat.
Hmm.
Oh, you're talking about like lives.
Anything for bad maths tomorrow.
Yeah, we having lives right through. Right. Hey, when I tell Oli I was gonna do lives, right? Like straight down. I mean it, you know.
Oh. I bio tomorrow, so how to do bad maths tomorrow.
Okay.
Tomorrow come.
Let me share my screen now. We go start. I find the maths exam. It looks sus. It didn't look like somebody make that exam. You could
Yeah.
probably imply what I mean by that when I say I don't think somebody make the exam.
Yes. So like
I never say that.
when I see those questions, I never see that in my past papers, sir.
Yeah. I don't think somebody do that paper. I think ChatGPT might have been
The whole paper.
responsible.
Yeah, the whole paper.
I
Right, so
find it out.
are you ready to start this scene?
Yes, sir.
Yes, sir.
If you want to join the Zoom, message me on WhatsApp with your full name, have appearance and a voice note saying you're not gonna waste my time, and I will add you in. Alright? That's what you want to do. My number is on my TikTok. If you want to join the lives, have appearance, message me there, have appearance and a voice note stating that you're serious. Alright? And I'll add you. Cool. I will tackle this scene. So dy dx, and this is differentiation. All you put on the camera and thing now with the vibes there, all them went dead. Wham. What's going on there?
Let's finish up something, yes, sir.
Oh, alright, so dy dx. What does this mean? A lot of people don't know what this means, you know. So I wanna ask Ollie, what do you think this means?
Change in y over change in x.
Right, change in y over change in x. Differentiation is just measuring the rate of change between one variable and another. So change in y over change in x. So in other words, dy dx tells you the what? What do we call change in y over change in x?
The gradient.
The gradient.
The gradient. Now, why would we need a gradient function? So dy dx it produces a gradient function. Why would we need this? Well, let me look at a line. This is what a line does look like. And do you know that's what a line does look like?
Yes, sir.
Right. If you measure, alright, so watch. Look at this, right? Do you think the gradient is changing for a line or is it same?
Same.
Same.
Right. So at every single point of this line, the gradient is the
Same.
Same.
right, same. So do you think we need a gradient function for this or like find any gradient like normal is fine?
Fine, gradient. Great.
Like normal is fine.
Yeah, like normal.
Yeah.
Like normal.
Point is the same. I find this pen cannot tick, boy. Hey. Right. Now let's look at a curve now. Let's look at a curve. Let's look at a quadratic function per se. Remind me, what is the general form of a quadratic function?
ax squared plus bx plus c.
Right. Let me just say this is a quadratic curve here with the function with f of x is equal to ax squared plus bx plus c. So in maths, in regular maths, you would have learned that to find gradient at a point. Let me just say ask you to find gradient at this point, right? Wouldn't you draw a tangent to that point and find the gradient at the tangent?
Yes, sir.
Yes or no?
Yes, sir.
Yes, sir.
But let me ask a little. Let me just consider a different point now. Let me consider this point over here. Let me ask that question. Do those gradients look the same?
Not
No,
really,
sir.
because it's coming onto the curve.
Not really. They look very different. And so what's happening here is that wait. Let me see if I can get like a interactive. Give me a second. See if I can show you this. Give me a second. Yes. Nice. Let me show you something. Let me show you all something. Right. Are you seeing the screen?
Yes, sir.
All right. Check this out. Wait a. All right, check this out. I want you all to observe something. Are you seeing what I seeing?
Yes, sir.
Is the gradient the same at every single point?
No,
No, it changes.
It changes. Right. So we have to come up with a gradient function for this. Right?
So what happens at many?
That's GeoGebra. I've been telling you guys about GeoGebra a long time now.
All of
GeoGebra
that
is
is
goated.
GeoGebra?
Yes, GeoGebra is goated. Yes. I've been telling you guys the source for the longest while. You haven't been hearing me. GeoGebra is insane. Right, so we understand that the gradient for a curve is different at every single point. Gradient changes at every point. So we had to do something about that. So here's what I'm going to consider. I'm going to consider a curve here. That's what I'm going to do. And I'm going to draw up the Cartesian plane quickly. So here what I teach you already whole lot of differentiation in one night. If I may, I'll do that, right? A whole lot of differentiation in one night. From nothing to everything. Here what? Say we wanted to find the gradient at this point. Are you with me, right? Say we wanted to find the gradient at this point. Are you with me or not?
Yes, sir. I'm with you.
Alright. Let's just call this point. Let me just call this point what? What do I want to call the point? Well, we can probably call this x. And well, you know that the curve is formed by a function, a quadratic function, so f of x. So if I were to plug this x value into my function, what would I get over here?
You'll get Y.
I'll get y, but if we write it in function notation, we would say f of what?
F of Y.
Now f of x.
Oh,
Nikolai,
F of
Nikolai,
X. Okay.
Nikolai. And when you want to get the y value, you take the x value, you plug it into your function. So wouldn't that be f of x?
Yes, sir.
Yeah. So here's what I'm going to consider. So, Mikkel, wouldn't it be possible for me to like approximate the gradients?
Yes, sir.
If you don't understand what I mean, let me show you something. Consider another point here, right? If you draw a line passing through those 2 points, like so. By the way, this is first principles, eh? And I think it could come this year because CXC moving kind of sus. Question: doesn't this look really close to the actual gradient here? It looks kind of close, right? Doesn't it look kind of close? The black
Yes.
line. The
Yes,
black
sir.
line looks kind. Sir, are you having a life for art maths? Somebody asked me if I'm having a life for art maths. Watch it tell him, boy. Watch it tell him.
Uh,
Watch it tell him, boy. Watch it. Hey.
What
Are
I
you
was,
just-
sir?
all right. But here's what I'm saying, guys. This is the actual gradient at this point, and then we have an approximation on this black line. Don't they look similar?
Yes, sir.
They
yes,
do
sir.
kind of look similar. If I take this purple point and I bring it closer to the green point, what will happen to the approximate gradient? Will it become more accurate or less accurate?
More.
Are you seeing that? Yes or no?
Yes, sir.
Okay. If you're not seeing it, let me give a little more drastic example, right? Something more drastic so you kind of understand what exactly happening. If I take this purple point and I put it over there, right? And I draw a line passing through these two. Okay, that looking accurate to the actual gradient we want?
Nope.
Yes or no? We want the gradient at the green line, you know. We want the gradient at the green line. Does that look accurate?
No.
Nah.
Nah.
Yes, sir.
The actual gradient that we want will look something like so. This is what it will look like. This is what it's going to look like. But I have a question though. Let's consider the purple point is getting closer to the green point. Let's see what's going to happen then. You know what? I'm gonna leave this, right? This is what we start off with. Let me move the purple point a bit closer to the green point. Does the gradient start to look closer to where it's supposed to be?
Yes, sir.
Yes, sir.
Here what? Let's move the purple point even closer. Even closer. What are you noticing, boy? What are you guys noticing?
Very close to the original part, to the green.
So as you go closer, the gradient has a more accurate value.
Exactly. So we're getting somewhere. So I hope you all could understand that. Mikhail, can you see that as the other point gets closer to the actual point, the approximate gradient gets closer to the actual gradient at the point?
Yes, sir.
Yes, you could see that. You can see that. So what exactly am I telling you guys? So wait, let me just put this point over here, per se, and let me just draw a black line passing through both of these. We'll call this the approximate gradient. And here what? We're going to call this other point. Let me explain something, right? If we call this distance in the middle h, if we call the distance in the middle h, right? Then what would this x value be?
X plus H.
Yes, it would be x plus h. I'll catch that or no?
Yes, sir.
Yes, sir.
Mikhail, if you're confused, right? If I told you that this was 1 and I tell you I had a distance of 2 here, what would you tell me this point is?
1 plus 2,
Which is
3.
3. Bam, 3. So if this is x and I tell you the distance is h here, what would you tell me this is? Mikhail?
See, I can repeat back that.
No problem. So I gave you an example just now with numbers and I told you that was 1. The distance here was 2. What would this point here be?
Well, the numbers will be 3.
It would be 3, right? 3. So you just added 1 and 2 and I got
3.
3. Good. So if this is x here and you have a distance of h here, what do you suppose this point would be called?
X plus H squared.
Exactly. No, just x plus h. X plus h. And when I gave you the example just now, when I told you that was 1 and this was 2, what did you tell me the point was?
Oh, yeah. It's 3. It's 3.
3, right? So you just added 1 and 2. So if I tell you that this is x and this is h, what would this be?
X plus H.
Making sense?
Yes, sir.
Good. Okay. And if I wanted to find the y value for that, what would I do with that x plus h value? What would I plug that? Tell me, Mikhail. If I wanted to find the y value for x plus h, where would I plug that into? So Mikhail, if I want to find a y value and I have a function, what am I going to do with the x value? Regular maths here. I'm not trying to tell you this is regular maths. You have a function, you have a set of x values. What are you going to do with the x values to get the output? What are you going to plug that into?
You have to substitute X for something to get what Y is.
Yeah, so like, let me go back to regular maths, right? Because I did this in the maths live. Let's see how much thing we do in our maths live, boy. Real thing, boy. But Mikhail, look at this example over here. Remember, you do this in regular maths. You know, you have your domain over here and you have your range. If I tell you the x value is 1, how you gonna find the output?
Substitute 1 into the function
Okay, good. If I tell you the x value is x plus h, how are you gonna get your output?
You would have to substitute that to get what the output is.
Exactly. And if I'm putting that into the function, wouldn't I call that f of x plus h?
Yes, sir.
Good. So everybody with me on that?
Yes, sir, with you.
Yes, sir.
Okay, good. I'm running back one more time. So what are we interested in? We are interested in finding the actual gradient at this point. That's what we want to do. Right, Mikkel? We want to find the actual gradient at this point. And in regular maths, you learn that you just draw a tangent and find the gradient of the tangent.
Yes, sir.
Okay, so here's what I'm proposing. Consider you had some other point. And if I connect those two lines and draw a line through it, doesn't that gradient look sort of close to the actual gradient we want?
Yes, sir.
Yeah. And Mikkel, if I take this point and I bring it closer to the actual point, the approximate gradient is going to get more accurate or less accurate?
More accurate.
More accurate. Good. So here's what. Let's call the original x value for the point. We're going to call it x, right? Let's call the distance in the middle h. If I say that the distance in the middle is h, what would the new x value be? You had told me this before. So this is x.
Oh, x plus h.
Good. X plus h. Nice. Let's look at the y values now. So Mikkel, if you have a value of x and you want to get the y value, I would take the x value and where would I put it?
Put it
If you
into
have
the
a
function.
right, you go put it into the function. So I would say f of x. This is our new x value. Our new x value is x plus h. So to find the output, I would take it and plug it. You're gonna take that x value and plug it into
Your function f.
right, and I'll be f of x plus h. Great.
Yeah.
Good. We're going good so far. And so, Mikkel, what would this point be? The green point. Tell me the x value and the y value.
I'll watch it from my notes. F of x plus h.
Nah, no, wait, Mikkel, close your book and thing. You're learning this for the first time. It's fine. Close your book and thing. We're learning this. Forget about everything you know before. You're learning this for the first time. So, Mikkel, when you're calling out a point, right? Wait to say first.
The x value.
Right. What's the x? What we calling the x value for this?
X plus h.
Watch it.
Or x.
X. What is the quote unquote y value?
F of x.
F of x. Nice. Talk to me, right? Let me do that for the purple point. What is the quote unquote x value for the purple point?
X plus h.
Right, x plus h. What is the quote unquote y value for the purple point?
F of x plus h.
Hello, are you with me?
Nah, sir. I would tell you.
Right. So if I wanted to find the approximate gradient, we could call that m. Why not? Remind me, Mikkel, what's the formula for gradient?
Y2 minus y1 over x2 minus x1.
I bet. So what we're creating right now is a gradient for the black line, and that's the approximate gradient. You agree? That's only true gradient, you know, Mikkel. That's only true gradient. It's just our what? That black line is just our what?
Estimation.
Just our estimation. Good. We could probably call this x1, y1. And what will we call this then?
X2, y2.
Good. We'd call this x2, y2. Mikkel, hey, your whole perspective on our maths are going to change, you know. Because I can't teach you why it is do way it is do. So, where's y2?
F of x plus h.
Where's y1?
X.
Nah, that's not y. That's not y.
Y1. F of x. Sorry.
That's okay. Don't say sorry, you're learning. What is x2?
X2. X plus h.
What is x1?
X.
X. Good. Good, good. So let's continue, right? So that would be f of x plus h minus f of x. And in a denominator, we could potentially simplify. We could. So we have x plus h minus x. What is going to cancel off there?
That would just be H.
That'll just be h. That would. So Nikolai, Mikhail, Virginia, yeah, Lucas, Nishana, everybody that just do add maths. Now you guys know where this thing from first principles come from. Because if you Google first principles formula, you're gonna see f of x plus h minus f of x over h. Do you know what I'm talking about or not?
Yes, sir.
No, but I'm following.
No, that's okay. That's okay. You in form 4. You wouldn't know. You wouldn't do this yet. You wouldn't.
Yeah.
But everything makes sense so far.
Yes, sir.
Yes.
I'm understanding.
Until you know how to find gradients, you know y2 minus y1 over x2 minus x1.
Yes, sir, for sure.
Right. I just generalizing things instead of using numbers. Instead of using numbers, right? I'm using letters in place of numbers because if you use letters, we could swap out letters for what? Or we could swap letters for. Come on, guys.
Numbers.
Exactly. Because letters are variables. That's what letters are. Letters are variables. We could swap them out for numbers. Good. So we're generalizing the statement. Now, if I wanted to find the actual gradient, we could take limits. Remind me, guys, as the distance between the actual point and the other point gets closer, so like as h gets closer, the gradient becomes more accurate or less accurate?
More accurate.
More accurate. Mikkel, do you understand that if I take the purple point and I bring it closer to the green point, it's going to get closer and closer to the actual gradient?
Yes, sir.
So, Mikkel, when h is 0, can you agree that h is just the distance between the 2 points?
Yes, sir.
You can see that, right? I hope I'm not confusing you.
Yeah.
Watch. H is
Sure.
literally just the distance. So if the distance between them is 0, it would mean that at that point, the purple point is on top of the.
The green point.
Yes,
And
yes,
to
yes,
tend
yes,
closer to the original point.
yes, yeah, Nikolai, you catch what I'm saying, right, Nikolai? If
Yeah.
Nikolai, if the distance between them is 0, it would mean that both of them are.
Together.
Yeah. Watch, Nikolai. If I take this purple point, right, and I take it, right? I take this purple point, and I bring it closer and Nikolai. At this point, what's the distance between the 2 points?
0. They could be the same.
0. And at that point, the gradient would be 100% accurate. So what we could do is we could take the limit as h approaches what?
0.
Yes. Yeah, and I'll understand why. Because as the distance closes in, the gradient gets
Less
More
than
accurate.
more accurate. So that is why to find the gradient function, you say the limit as h approaches 0 for f of x plus h minus f of x all over h. That is why. Poof. That is why. That is the gradient function. And you would define this as f prime x, the first derivative of any function. Yeah.
Sir,
Oh, wow.
whenever we're doing questions, so just use ChatGPT to give you some questions, sir. Or
Oh,
some
boy, wait. I didn't understand why you said that just now, but I catch you. Nikolai, you're moving on a different wavelength there, boy. Oh. All right. So I want to do a question on this now.
Yeah.
Yes,
Yes,
sir.
sir.
All right. So remind me. And what do we call this? We call this as CXC says it in the syllabus is the intuitive approach to differentiation. That's what CXC calls this. Hope I can spell intuitive. I don't know if I spell that correct. I teach maths, not English. Intuitive. I even kidding, and this is literally what the syllabus says. Like if you go in the syllabus and you look, it literally says intuitive approach to differentiation. But they could have the TXE big on our sense, you know what I mean? They could have just say first principles.
Yes, yes, spell it right, so.
English vibes, English vibes. Are you ready for English vibes, dog? Are you ready for English vibes?
Yeah, but,
Ah,
but English don't go ready. Or probably for English B. No, English B don't go
ah
ready.
boy. Yeah, boy.
Okay.
So now that you all understand the concepts, you can derive it if you forget it in the exam. But let me try to remember it now. Let me try to remember it. So how do I define the first derivative using first principles?
Is F in brackets X plus H close brackets. Is it minus or plus? Plus. Oh, minus.
Nikolai, you tell me, Nikolai. Nikolai, we find an gradient. Find an gradient.
Right, minus, yeah.
Right, because Nikolai, what's the formula for gradient, boy? Gradient, what's the formula for gradient?
Minus y1 over x2 minus x1, right?
You see, Nikolai, if you understand the thing, you will never forget it. You know it's
Yeah.
minus because it's gradient you're finding, right?
All over h.
Yes, yes. Good. Remember that, guys. But I'll never forget something. This is the approximate, you know. This is the approximate gradient. To find the actual gradient, you need to take limit as h approaches.
0.
0.
Yes. Yes. Big up on yourself, boy. Big up on yourself. Let me do a question now. 2025. No, this is maths. If this come in the exam, don't forget to tag me. I feel like
The
it might come.
question or the procedure?
Procedure.
Okay.
Right.
I'm not trusting CXE now, in a sense.
Yeah, shouldn't. Oh, I want to, I had come up with an hard maths test using AI. I want to do that test at some point, or
Yeah,
Sure.
So,
send
Yes,
you a
sir.
copy
do the AI
and
now,
that
so.
we do it and see
Se-
who get the most wrong.
since CXE want to generate AI thing, boy, suppose we could do that.
So then just decide to not just copy questions back in the years no more, then just decide, let me just pull up a new whole thing, that's it.
I feel like what I do.
So when I
Um,
see that ratios question wasn't like the ones I do, I start to panic.
it's out of panic. I don't find the ratio questions was that bad. I don't find it was that bad,
No, but
person.
it's like, it's the first time we see this question, and I know I was doing past papers.
No, I still wouldn't say it's that bad. All right. So if it does come in the exam, which it did come in 2024, this is what it's going to look like. So Nikolai, read A part 1 for me.
Using the definition of derivative as a limit of that's all. Okay, that's all.
I really need to do our
Right.
English vibes, boy. Really
Yeah,
need to do our
yeah.
English vibes, boy.
Use the definition of the derivative as a limit to find f of x for the function f of x is equal to x squared minus 3.
Right. So let me understand what they're saying. What did they say, boy? They say use the definition of the
Differentiation. Well, derivative.
right.
Derivative.
What is the definition of the derivative, Olia? Remind me. It goes like this: f prime x is equal to what?
F of x plus h minus f of x over h.
Again, we're forgetting something, we're forgetting something.
The limit h to
The
0.
limit
Limit
Right.
h tends to 0.
Because this over here is an approximation. For it to be accurate, h needs to approach 0, meaning that they're overlapping. The 2 points you pick overlapping. Okay, let me start from our side. This not hard. This not hard at all. It's looking hard, a little bit not hard. This easy. So, Nikolai, here what we have to do, right? You see, now we have f of x plus h.
Yes, sir.
We had to find f of x plus h. Don't we have a function?
Yes, sir.
Here we have a function. Our function is f of x is equal to x squared minus 3. So I'm going to plug in f of x plus h into the function. So anywhere I see x, I'm going to replace x with what?
X squared minus 3.
Nah. Wait up. What we want to find?
Oh, f of x is equals to, no, f in brackets x plus h.
Right. So what we plugging into the function?
The x squared minus 3.
Nah, boy, Nikolai. But
It'll
No,
be
my brain not clicking.
x plus h. We're trying to find f of x plus h.
Nikolai, what we have inside the brackets?
The x plus h.
Right. Wherever you have inside the brackets, you're gonna replace x with that. So anywhere I see x, what am I going to write instead?
X plus h.
That is all, x plus h. And so we're going to say x plus h squared minus 3. You understand?
Yeah.
Nikolai, watch. If I had put 1 in the bracket here, what am I going to replace x with?
With 1.
If I have x plus h in the bracket, what am I going to replace x with?
With x plus h. Sir, you know what? You know when I saw the x plus h, I thought it was gonna put the top one inside the other one. So
Oh, no. All right. So let me expand this thing now.
is this
So wait.
2024 by chance?
Yeah, this is 2024. So x plus h squared means x plus h by,
X plus H.
right, that's what it means, right, Nikolai? X plus h squared means x plus h by x plus h. Yeah, you okay with that or not?
Yes, sir.
Right, minus 3. Now we need to expand the brackets quickly. So you're going to say x by x. You're going to say x by h. You're going to say h by x. And you're going to say h by h. What is x by x, Nicholas? I say Nikolai. Yeah, what is x by x?
X squared.
Right, what is x by h?
Hx. Well,
Right,
x,
hx. What is h by x?
hx,
Right, what is h by h?
h squared.
Good, let me look to simplify. What like terms are you seeing?
The hx.
So how much hx's we have?
2 of it.
So I'm going to say 2hx.
Yes, sir.
And the constant terms. So here what, right, Olia? A constant term is defined as any term that does not have a variable in it. The variable we're looking at here is x. X is a variable. So does the h have a variable in it?
No,
No.
sir.
No. Does we're asking, does it have an x in it?
No.
No. Does this have an x in it?
No,
No.
sir.
No. So technically both of these are the constant terms, right? So that's going to be plus h squared minus 3. That's what it's going to be. So guys, this is our f of x plus h right here. Okay. That is f of x plus h. So probably wondering, so why we find that? We found that so we could plug it in into the definition of a derivative. So we'll say the limit as h approaches 0, and instead of writing f of x plus h, what do you think I'm going to write?
X squared plus 2H plus X squared minus 3.
Virginia, are you sure you're in form 4?
Yes, sir, I'm sure.
All I feel Virginia trolling, I feel like she's trolling.
No, sir,
What
I
I
say
think?
I promise.
Michael, what you think? You think she's trolling? Lucas,
So she had to be trolling.
I feel so, you know.
No, sir, I'm home for real. I just started vectors today.
Hey boy, bad. Right? Minus f of x. So here what, right? When you say minus f of x, can I just go and write minus x squared minus 3?
No.
What am I missing there? What am I missing? I'm waiting, guys. What am I missing? X squared minus 3 is a binomial term.
Yep.
What am I missing?
A bracket.
I'm missing brackets earlier. I'm missing brackets. Anytime you have a binomial term, like x squared minus 3 with 2 terms and a plus or minus in the middle, you put your brackets. Yeah, this is hard maths. Why people ask me if it's hard maths, boy? I literally, like when you join the TikTok live, it's telling you hard maths live. But anyways, All you understand why I put the brackets? Yes or no?
Yes, sir. Oh,
Yes,
yeah.
sir.
I think so.
All right, and I'm gonna put this whole thing over what?
H.
H.
Wasn't it supposed to be some other numbers? I mean, some other letters, and then it would have became H?
No. We just learned just H. You know why? Nikolai, what would x2 have been? X2 was x plus h, and what was x1? X1 was just minus and minus x. When you simplify that, what is x minus x?
It could be H.
It would
So
just be h.
just cut to the chase already.
Yeah, we just cut to the chase already,
Okay.
right? Here what we had to do, we had to simplify the top. We have to simplify the top. So you see how we have the minus on the outside? If you distribute the minus across all the terms inside the brackets, what will you get?
Minus
X
x squared plus 3.
Plus 3.
Right. What like terms are you seeing on the numerator?
The X squared.
All right, we have x squared and minus x squared. I'm not going to cancel off,
Yeah. And
Minus 3 and 3.
right? They're going to cancel off.
So I was going to say you would just take out the H from the underneath and the H on top, But then I realized that could be wrong.
No. That would be correct. But when you see this minus 3 and this plus 3, forget about that. Where's
No,
minus 3 plus 3?
So I'm talking about the H.
Don't worry, we can do
Zero.
that just now. Where's minus 3 plus 3?
0.
Yeah. So what does it become on top?
2hx plus h squared over h.
Now, let me ask a little question, right? You see this limiting? This limiting, the hardest thing about limits is to rearrange your expression to get rid of anything in the denominator. Let me explain. You're probably saying why I'm saying that. Dog, limits is just plugging in whatever value you're going to. What value are we going to here?
0.
0.
We're going in 0. We have a h in the denominator. If I replace h with 0, what happened there, boy? We could divide by 0.
2hx
No.
plus H squared.
But Nikolai, we could divide by 0.
No.
No, so you can't plug in 0 just yet. You need to get rid of that h from the denominator. So let us see if we could pull out a h from top. If we pull out a h from top, what are gonna be?
From the H squared.
Gonna pull out a h from that. I wanna write on the inside.
2x.
Will be 2x plus h.
Plus H.
What's gonna happen there?
You
h
cancel.
and h will cancel.
Right.
Oh.
And just like that, we would have gotten rid of the h from the
From the denominator.
yes, and now you can plug in h as 0. If I plug in h as 0, what will I get?
2x.
I'll get 2x. Nice.
One
Badness,
question, sir.
badness. Yeah, Nikolai?
Couldn't you just take off the H from the underneath? Just by me asking. From
If
the
I,
from the initial beginning where we was canceling off the numbers that was like terms.
nah, you can't do that.
Alright.
To cancel off something from a denominator, you need to be able to write it as a multiple. You need to be able to write it as a factor of it on top. Like, okay, some students go do this madness. Are they feel illegal?
Nah, I was talking from the
No,
H
sir.
squared, but no, that wouldn't make
Oh.
sense.
You're talking about like, okay, you're talking about from like here?
No. Okay, go back to the question. You
No,
see
sir.
where
I
you
think you
have
mean
the 2hx plus the H squared, like take off the H from the underneath from the H squared on top. That's what I'm talking about.
Wait, like this? Or you
Yes,
mean like pulling out the H? Wait, you mean like this?
yes, sir.
That illegal. That is very, very illegal. That's very. Somebody wanna tell Nikolai why that illegal? You know what, Nikolai? I will show you why that illegal. I will show you why that's very illegal. Nikolai, say for instance we had 1 plus 3 squared all over 3, right, Nikolai? How would you work that out? What would you do? How would you work that out?
I'll work out the one on top first.
So that again, yeah, you work out everything on top first. If you say 1 plus 3, so there we go.
You'll get 10.
You get 10, right?
Yes, sir.
And the answer is 10 over 3, yeah? 10 over 3.
Yeah.
I'm asking a question, Nikolai. If I do what you're suggesting, that'll be 1 plus 3. What is 1 plus 3?
4.
Is that the same thing as 10 over 3?
Nah.
No. So you can't. Let me explain something, Nikolai. If you had a situation where you had something like let me just say you had 9 plus 27 all over 3. Do you recognize that we could potentially pull out a 3 from 9 and 27?
Yes, sir.
Yeah, if you pull out a 3 from 9 and 27, we go right on the inside.
3.
Wait,
And
my Apple Pencil playing up. My Apple Pencil playing up. Give me a second. I can't wait to make it bigger and just have all the best equipment and just teach for free, though. Can't wait. Can't wait, though. Oh. Alright, if I pull out 3 from 9 plus 27, what that will be?
9 plus. I mean,
Yeah.
3 plus 9.
What is happening for, boy? Yeah, that would be 3 plus 9, yeah?
Yes, sir.
Give me a second. Maybe I need to change the Apple Pencil tip. I care like I better buy a Samsung tablet, but I better buy a Samsung tablet and
So the new Tab 11, I think, is the S11 come out. I go on trading, but not trading. It have places you can trade in and you pay the difference.
serious?
Yeah.
I didn't know that, boy. If I buy a tab, I'm gonna buy the tab, the latest Ultra. Cause I just need something that good for performance.
Excuse me, Michael. You could trade in phones as well?
Not at the official Samsung store, but I have other businesses that you could trade in and pay the difference. Once they analyze the condition of your current device.
Alright, no problem.
Yeah. Here what, guys? All good thing guys are Apple fanatic, but I have a OnePlus 12. I have a S24 Ultra. I will never get an iPhone. I will never get an iPhone. Never. I
Nah,
like MacBooks are good though. MacBooks are really good. MacBooks are really good.
but they're very expensive though.
Yes.
So
They're very
remember, I was
expensive.
talking about Xiaomi. Okay.
Sha-
This is my old
boy,
phone.
big up Xiaomi one time. Big up Xiaomi one time. Yes.
So the
So,
difference between that phone and the S22 is way different. I find
yeah,
this phone was way better.
Man had 2
it
phones?
is. It is. Like my OnePlus, the camera is better than my S24 Ultra.
Yes, sir. Let you get back to work now.
Yeah, Nikolai locked in. Yeah, Nikolai. Here what, right, Nikolai? How do you work this out? Under normal circumstances, how do you work this out?
Well, I would have done that way, but if I was just playing around, I would have just take out the 3 from the stuff on top, which that
Wait, I mean even simpler than that. If you're just working this out, and you just say 9 plus 27, 9 plus 27. What's that? 9 plus 27 is what?
9 plus 27. Okay.
9 plus
36.
36. What's 36 over 3?
Like 12.
Like 12, right? If I pull out the 3, right? If I pull out the 3 from 9 and 27, and I cancel it off, I'm gonna remember 3 plus 9. What's 3 plus 9?
12.
12. Did I get the same answer?
Yes, sir.
Right. Good. So, Nikolai, this is what I'm telling you. If you could pull out a multiple or something from the top and have some number by some other number, then you can cancel off that number on the outside with the number in the denominator. You can't just, hey, if you see a sum or difference and thing, no, you cannot cancel off. So, earlier, if anybody watching this, hey, do this in your hard maths exam, I'll come for you. Do this. Right, Nikolai, do that.
So I know the procedure, but it's just like I was just thinking of other ways, if there were other possible ways of doing it now, sir.
Well, it's a good thing you bring up this, right? Because when people looking back at this video, they're going to realize that illegal and they wouldn't do it. A lot of people do that in regular maths too. But guys, if you find the derivative of this, like us for the usual rules for differentiation, NT will just take the 2 minus 1 from the power, you get 2x, right? Yeah?
Yes, sir.
But if you did do that, you're going to get no marks. None. Because it's 4 marks. And this is what they want you to do.
Well, sir, you could probably just use that to see if your answer that you used the long way would have been correct.
Correct. That's correct. You're okay?
Yes, sir.
Yes, sir.
Well, I want to do another question like this.
Yes, sir.
Yeah, no
Yes,
problem.
sir.
I got another question. Oh, before I continue, right, let me explain something. So let me just go over the general rules for differentiation. If I have d dx x to the power n. When I differentiate this, what am I going to do to the power?
You're going to multiply it by, well, the outside, which would be
Right? So that's called pre-multiplication. So I'm going to say n by x. And what will I do to the power?
-1 from it.
Right, -1 from it. Everybody okay with that?
Yes, sir.
Suppose I had d dx ax to the power n. Same rules. I'll take the n and I'll multiply by the what?
A multiplied by n,
Right, an, and then I'll do what with the powers. What I do?
-1 from the power.
-1 from the power. Good. Now let me ask a trick question, right? Probably should not say that. I'm going to draw a constant. I can't even call this a function. Mikhail, I want you to answer this. Mikhail, what are all the equations for vertical lines? So like, let me just say I have I call this 5 here. Mikhail, what is the equation of that line?
Y equals 5.
Y is equal to 5. Let me ask all a question, right? Let me ask all a question. Let me ask you guys a question. When x changes, does y change?
No, sir.
Mikhail, when x changes, are you seeing the y value changing at all?
No, sir.
What is it saying at?
Y equals 5.
Right. So if I was wondering, that's why they call numbers constants. That is why. Because it does not change, it's constant.
Yes, sir.
Yeah. And okay. Remember, differentiation tells us the rate at which two variables are changing. Mikhail, what is the rate of change here? Is it changing?
No, sir.
No, so the rate of change is what?
0.
0. So that's why when you find the derivative of a constant, it is
0?
yes. That's why. Because
Right.
Nikolai, when x changes, does y change?
No,
No. So Nikolai, what's your rate of change then?
that'd be 0.
It's 0. Good, because it's not changing. I surely didn't learn the thing like this in school. Because people they just tell you they just say learn this, move on.
Yes,
But
sir.
I hope all you understand why it does work now. This is why we just say the things we just say. You
Excuse me,
understand?
sir.
Yeah, talk to me.
What's a lim? The
Lim,
LIM.
that means limit. That means limit. So like, I'm not sure how long it was here for, but consider you have two different points here, right?
Mm-hmm.
I said that the gradient would be most accurate when this point gets closer to what? I'm not sure how long it was here for, but the gradient will be most accurate when the purple point is close. When is what?
I didn't come until like recently, so I have no idea.
Oh well, I'll tell you to watch a YouTube video then. But let me just tell you this, right? The black line you are seeing is something called the approximate gradient. It's not 100% accurate. It's an approximation. But as the purple dot gets closer to the green dot, the gradient is going to be 100% accurate. So as you could see, Thomas Xavier, as I bring the purple point closer to the green point, what is the distance between them becoming?
Smaller.
Smaller. And eventually it approaches what?
Mm,
If they're on top of each other,
symmetry.
if like they're right on top of each other, what's the distance between them?
0.
Exactly. So I'm saying the limit as h approaches 0. So like I'm constantly bringing it closer and closer and closer and closer and closer and closer and closer. So I want to find the limit as it approaches a specific value. That's what limits are. Like you want to see what happens to a function as the input approaches a specific value.
Yeah, because my teacher never used limits in class, so I had no idea what that was.
Oh, no problem. I feel like it's how CXC moving sus. CXC moving real sus now, so I'll have to teach this because this come in 2024 and you had to know limits, you had to know the the definition of a derivative to answer the question. You had to know the definition of a derivative to answer the question, which is this. So let me give you all a question. I'm gonna ask ChatGPT to make a question. And I don't know why, but I'm not gonna say it.
Yeah, we're not going to talk about it.
Right. Generate new chat. Generate a first principles question for my Form 5 CSEC Art Math class. Let me see what ChatGPT generates. Are you ready?
So,
All right, bet. Virginia, see you raise your hand.
Yes, sir, I have a question. Could you write your final answer as equal to x, or do I have to put like the f1 x limit as h approaches 0? How do I write
Oh,
my final answer?
all right, so to write this is your final answer. Like, okay, you would say f prime x is equal to that.
Oh, okay.
You see this whole thing over here, this whole process? That whole process is how you find the derivative. So when you're done, you would have successfully found the derivative, and this is how you write the derivative. You see how we have one dash on top?
Yes, sir.
That is telling us we found the first derivative of the function. That is what it's telling us.
Oh, okay. Thank you so much, sir.
No problem. I feel like this girl trolling, but she'll be trolling.
Sir, I'm
But
not sure.
what school you at?
St. Francis Women's College.
Okay, I've heard good things about that school.
Okay, great.
Yeah, I taught a girl from that school pure unit 1 and unit 2 pure maths, and she got a 1 in unit 1 and a 2 in unit 2, and that was like in 3 months she did that.
Wow, that's so cool.
Yeah. Keep in mind, I taught her when I now finish upper 6, yeah. I now finish upper 6.
That's crazy. That's crazy.
Yeah, I really love maths. Alright, so here what? I'm going to give you all 3 minutes to attack this question. Go, 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 go. Speed. Speed. I'm gonna check my messages. All right. I feel like if I make a video telling people how to do hard maths, it will have more people because I feel like, and generally speaking, nobody is do hard maths really, nobody's really do hard maths. But hard maths better than maths though. Hard maths better than maths. Yeah.
Math's about to save my math grade.
so there was a time where I passed art math and failed math in a sense.
Boy, hey, let me tell you something, right? That's so true. That's so true. I used to get 70s in maths in school and 90 something in hard maths. And that means I never used to revise for maths too. I used to do real hard maths too. Real hard maths. I used to real do hard maths. And if you do hard maths, you see all of them questions in maths with algebra and functions and everything, you can get 100% correct. You don't even have to blink your eye.
I should have done that then.
Yeah.
This is a very big thing I'm working with. So
If I like you get this question correct, they got police it. So after this, we're going to look at some more rules for differentiation. I want to finish like 11 or 12 because I need to get sleep. I've been killing myself the past few days.
So I might have to go just a second.
No problem. I wish you the best of luck for your exam.
So,
People,
So-
I would say, yeah, Nikolai,
you want to write bio for me or you know biology?
I do biology, but it's not my favorite thing. All right, I'll again show the question.
So I was confused for a moment until I saw the underneath question, sir.
Oh, they're saying hence determine the gradient of the curve at the point where x is equal to 2. Remember, you are finding for a function, the gradient function, and the gradient function would accept our input. And they're telling you the input is x is equal to 2. So cool. Let me start, right? Let me start. Michaela, I see you still writing. You get thrown now.
Yes, I know reach the part where doing the limit part.
Okay. All right, so we're gonna start the question, right? We're gonna start because hey, all you need to be able to work on that pressure, work on that exam pressure, right? Or you can't be taking any amount of time you want in the exam. So the marks Nishana, tell me what is not Nishana in there.
Yes, sir.
All right, so Nishana, you good?
Yeah.
Big up, big up. All right, so using first principle. You see that first part? Using first principles. Remind me, what does first principles tell me?
Like you're finding the limit, so basically the gradient.
Right, so that'll be limit as h approaches 0 for what?
What?
So we limit as h approaches 0 for
Yeah.
what?
F open brackets x plus h minus f of x all over h.
Good. What is our function in question?
3x squared minus 4x plus 7.
Right, so we already have f of x. What function do we need to find? Or no, I shouldn't say function. What do we need to figure out for?
F of x plus h.
Good. So anywhere I see x, I'm going to write what instead?
3x squared minus 4x plus 7.
Nah, anywhere I see. Okay. What we have inside the brackets here?
X plus h.
Right, instead of.
We're so confused.
All right, so forget about the x plus h thing, right? Just think of regular maths. If I had a 1 inside the brackets, anywhere I see x, I'd replace it for what?
1.
Okay, what have in the brackets here?
X plus h.
So anywhere you see x, you're going to replace it with?
Oh, x plus h.
Right, right. So you see how I have x squared, instead of writing x, what am I going to write?
X plus h.
To what power?
2.
Right? And I'll say minus 4, open bracket.
X plus h and then plus 7.
Good. So we have to expand this first. So that'll be x plus h. If you expand this one though, here we go.
4x, wait, minus 4x minus h plus 7.
Oh, you figure minus 4h, right? Minus 4h.
Yes, sir.
People on TikTok earlier, this is add maths earlier. This is add maths, not CSEC maths. Some people let's do add maths. You know what I mean?
So like they're ready for Jan.
I don't know why. Let me see what happened, John. I'm real curious. All right, Nishana. Now we need to expand this. So you want to do the full thing or you already know what I'll be?
I already know it would be
It will be x squared plus
2x h.
yeah, plus
2hx plus h squared.
Now we need to expand our brackets. Expand that for me.
3x squared plus 6hx plus 3h squared.
All right, let's group together any like terms we're seeing. What like terms you seeing?
I don't know if I'm supposed to be seeing something.
So like I'm gonna explain what I mean, right? Truth be told, there really aren't any like terms in them.
Yeah.
The only like terms I am seeing is the 6hx and the minus 4x. If you understand what I mean, both of them are x terms. Both of them
Yeah.
are x terms. So how would I look like? That would look like 6h minus 4x. That's what it would look
Yeah.
like. What time so I'm actually gonna write that. So I'm gonna write all the x squared terms first. You just have one x squared term, so I'll write that back. Then I'm going to write the x terms. I have 6hx. I have minus 4x. Then I'm going to write, okay, so Nishana, all the terms that don't have x in them, they are the what? What kind of terms you call those?
I don't know.
Okay, what do you call 7? 7 is an example of a what?
A number variable.
A constant. Constant.
Well, yeah.
Because a number remains constant. It's just a number. So if it doesn't have x in it, it's a constant. Right? It's a constant.
Yes, sir.
Good. And so the constant terms, could you tell me one of the constant terms?
7 or like 4h.
This is a constant term. This is a constant term. What other constant term you're seeing?
3h squared.
3h squared. So I'm going to say 3h squared minus 4h plus 7. Yeah?
Yes, sir.
And if you want, you could always pull out the x there. Okay, we do as much as we could, right? We do as much as we could. Actually, here, I recommend leaving it like that. Leave it like this for now. Leave it like this for now. Leave it like that for now. Yeah. So Nishana, now we're going to substitute this.
Okay.
So what did I find f of x plus h to be?
3x squared plus 6hx minus 4x. Yeah, so on.
And then we're gonna say minus f of x. So
Yeah.
could I just go and write minus 3x squared minus 4x plus 7?
Yes.
No.
No, wait, no.
It's minus f of x, minus the whole thing.
Yeah.
Is 3x squared the only thing in this?
No.
Nah. So see if you can correct me.
We're still lost now.
All right. So let me explain something, right? F of x. What is f of x? Remind me. What is f of x?
3x
Remind me.
squared minus 4x plus 7.
So if I ask you to say what minus f of x is,
It'll be the negative state.
but would it be just negative 3x squared minus 4x plus 7?
No. Because
What's property?
you're supposed to put it in brackets, minus brackets, 3x squared minus 4x plus 7, close brackets.
Good. That's what I'm saying. That's what I'm saying. Right? You need to take the negative and apply it to each term in f of x, not just the 3x squared.
Yeah.
Right? That's what I was saying. So we minus open brackets 3x squared minus 4x plus 7. And that's gonna be over what?
H.
H. Imagine the math people looking at this. Cracking up, though, cracking up. Imagine the regular math people that think this is regular maths looking at this.
Yeah, they go regret writing maths. Like they go say, well, at least I tried.
Yeah. So Nishana, expand our brackets for man, tell me what we'll get.
Minus 3x squared plus 4x minus 7.
All over.
Each.
What cancel of there?
4x and 4x, 3x squared and minus 3x squared, and 7 and 7.
Good. Nishana, it's easy, you know? It's easy. The question just looking complicated.
Yeah.
You see that cake butter? You see that dumb question they bring?
I saw Coons bring up a cake.
Yeah, boy. Yeah, that's what it's make. That's what it's make, right? I hear that question. I didn't like it. Didn't like it. All right, so that'll be 6hx. What?
Plus 3h squared minus 4h all over
Michael,
h.
Michael, you understand that or not?
Yes, I'll finish all the question.
Okay, good. And that's gonna be over what? Nikolai?
H.
That's gonna be over h. So, guys, can we divide? Can we just directly say h is 0? Can we directly say h is 0 there?
Oh, because it can be
No,
done.
sir.
0.
No, you can't do that. So you need to factor out a h from the top. So, Nikolai, if I factor out a h from the top, what am I going to write?
H is equals to 6x plus 3h minus 4. One question, sir. Couldn't you just put all those over h, like 6hx over h plus 3h squared over h minus 4h over h?
Yeah, you could do that.
Okay.
Yeah, you could individually put them over h. That's fine. For
Okay.
those of you guys that are not understanding what Nikolai is saying, he's saying like, so you could write 6hx over h. You could write 3h squared over h. Nishana, you understand what he's saying or not?
Because isn't it the same thing? Because
Same
when you
thing.
add it, it's just h
Same thing.
over
Same
h
thing.
numerator on top.
Same thing. Nishana, you understand this or not?
Yes, sir.
Okay. Okay, this is not regular maths. This is hard maths. These are hard maths. Yeah, these are hard maths. Yeah. So what I prefer to do, I prefer to factor out the h, or I just prefer to separate it into individual fractions.
Factor it out.
Factor it out. Nikolai, you're in the dark, boy. You're in the
No, I just
minority,
thought
but
I just thought of that was another winner, sir.
that's a good way though. That's a good way, Nikolai. That kind of thinking will help you when you're doing prof questions and things. Good.
Yes, sir.
What gonna happen to the h's there, boy? What gonna happen to the h's?
They'll
They'll
cancel.
cancel.
And what are we gonna end up with?
6x plus 3h minus 4.
Over nothing. Over nothing. Nice. And so now, since it's not over anything, we could plug in the 0. And what are we going to get?
6x minus 4.
6x minus 4. If you're confused, we're telling you that h is 0, right? We're telling you that h is 0. So anywhere you see h is going to be substituted for 0. And so it's going to be 6x minus 4.
So
Isn't that the...
let's scroll back. I didn't understand the second part where it say no in the question, you could scroll up. Yeah. I didn't understand that part, hence determine the gradient of the curve at the point where x equals to. I didn't understand that part. Like,
all right. Let me go back to something, right? Right, Mikhail? When I was starting off, I tell you that dy dx is not just a gradient, it's a gradient what?
function.
And a function accepts it takes a bunch of inputs, right? And it like would take different values for x.
Yes, sir.
Good. The gradient for a line is the same everywhere. Cool. The gradient for a curve, what happens to it?
It changes as the point tends to different places.
Exactly, the gradient changes. And so to find the gradient at that point, what I would do is I would find the gradient function and I would plug in the value for x at that point. To find the gradient at this point, Mikhail, I would find the gradient function and plug in the value for x at that point. You understand what I'm saying or no?
Yes, sir.
Would the value for x here and the value for x here be the same?
No, sir.
No. See, that's what I say. When you differentiate, you're finding a gradient function. And so you could find the gradient at any point. You just need to know the x value and you could find the gradient at that point. So I hope you understand now. They say determine the gradient of the curve at the point where x is equal to 2. Did we come up with the gradient function?
Yes, sir.
What's the gradient function?
6x minus 4.
Right, and that would allow us to find the gradient at any
Given point.
exactly. So to answer your question, it would just be f. What are we plugging into the gradient function?
2.
X is equal to 2.
Good, we're plugging 2 into it, 2 into the gradient function. And so that's going to be 6 by 2 minus 4. And what's your answer going to be?
8.
8.
Yeah, that's it.
So when I was working it, I thought that was like the limit, and I put the limit as 2. I was like, wow, that ain't working.
Nah. So it's a good thing we do a question like this. CSEC could bring a question like this for art maths. Seeing how they're moving these days, you know what I mean? Seeing how they're moving these days.
Yes, sir. Excuse, sir. You should, one more thing. Well, two things actually. One, I have to go. And two, you must put a video of a word of encouragement for all the subjects necessary because I'm watching the chat and a lot of people saying they are cooked and making me feel cooked as well, but I know I'm not that cooked.
Hey,
So,
boy.
like, put a video for a word of encouragement or something like that. That's it.
You see, the thing is that if you just wait, let me do a live reenactment. Let me do a live reenactment. I'll watch one, right? What is man doing there, boy? Nah, I can't do that. Wait, I cooked dog. You see, that is all most students is. But
Yes,
if
sir.
you sit down and watch the whole thing, you realize it's not that bad.
Oh, yeah. Because I know I do the maths good, right? And the people are talking on the chat and people on TikTok and everything posting up stuff like the maths was real hard, boy.
I don't find the maths was real. Okay, you see, for you to think the maths is easy, you must have a good foundation. The maths test could come how quote unquote easy. If you don't have a good foundation, you're gonna think that is crazy, right? Rocket science.
Yes, sir.
If you can't count, here, say if you cannot count, and I ask you where is 1 plus 1, you're gonna be cooked. Because you don't know what 1 plus 1 is, right?
So like that person with the 100%, the 100 questions, was it 100 marks equals 50% was 10% of that?
That's crazy. That was crazy. Hey, we should not be asking ChatGPT questions. That's so simple.
Yes,
We
sir.
should
But
not be asking ChatGPT questions like that.
other
Mikhail, somebody on. I don't want to shame them. I don't want to shame them, but like that low-key crazy.
than
They was
Yes, I
asking.
see. They was trying to calculate the total mark.
Oh, I just get so scared when I see things like that. Tell you, I just get so scared.
yes,
All
but
right,
yes, sir. Other than that, I have to go.
no problem.
I'll probably come back later on.
No
But
problem. Bye
thank
bye,
you.
Nikolai. Take care. All right. Hear what, earlier? Hear what? People asking, oh, when they're gonna use this formula. You are going to use this formula. Hey, Mikhail, read this for me here. Read this for me.
Using first principles.
Right, using first principles. That's when you know to use this, when they say using first principles, or if they tell you, use the definition of a derivative. You understand?
Yes, sir.
If they tell you, use the definition of the derivative, or they say, use first principles, you're using this. And the question, Mikhail, if you doing this question normally, right, and you can't finish this question in like a second or something, watch 6x minus 4, that's all.
Yeah, yeah.
And that'll be like a 1 mark question. However, you might see 6 or 4 marks or something if you had to do this. So you know when to use it, don't worry. Good. Right. Let me show you how to tackle some more questions. Right, so when you differentiate, right, so when you find the first derivative, that's telling you the gradient at the what at the point. Gradient at the normal or gradient at the tangent at the point.
Tangent.
Yes. And Mikhail, you understand what I mean on that?
Yes, I understand.
And if anybody is confused, let me give you a quick example, right? Quick example. Check that. What's that? That's that what? That's that what?
Somehow.
It's a curve, right? It's a curve.
That cool first.
Right. Mikhail, if I want to find ingredients at that point in maths, what you do?
Use the gradient formula.
No. Not any way
Oh,
you think. Remind me. If you have a curve, gradient is different at every single place. So you'll have to draw what first? You'll have to draw what at the point?
tangent.
Draw a tangent. So, Mikhail, when I find ingredient at this point, I really find the gradient of
The, the tangent at that point on the curve.
yes, yes, yes. And this line over here will be called the what?
The perpendicular bisector.
Nah, not necessarily. Not necessarily. But I see why you would say that though. See why you would say that. We typically just call it the normal. Right? And you have a point, Mikhail. They have a point. The normal and the tangent are always what to each other?
90 degrees.
Yeah, they're always 90 degrees apart. And if you have two lines and their gradients and they are 90 degrees to each other, then the gradients are going to be the what of each other.
Negative reciprocal.
Right.
So I was real revising coordinate geometry for maths for like the part for maths now. And I was
Mhm.
doing parallel lines on that and it come, but not to the extent I thought it would have come in that paper.
Hey, that paper was just crazy, buddy. Like, okay, funnily enough, right? The pass rates for art math is higher than the pass rate for maths. And the reason for that is the students that pick art maths are students that are generally already okay in maths. So you see the pass rate being higher. Because people that do art maths are people that are already good in maths. Right, so for perpendicular lines, the gradients are the negative reciprocal of each other. So okay, Mikhail, I have a question, right? If I tell you that the gradient here, by the way, this is kind of like a negative gradient or a positive gradient.
Negative.
Like a negative gradient, right? So what if I tell you that gradient was negative 3/4? Right? What would this gradient here be?
Positive 3/4.
Nah,
I
nah.
mean
Negative
positive 4/3.
reciprocal.
Yeah.
Positive 4/3. Yeah, yeah, yeah. So here what? Let me tackle some questions like this now, Mikhail. Since you say you practice coordinate geometry.
Yes, sir.
So earlier, I you see I like art maths a lot more than maths, eh? I like it a lot more than maths. So I gonna and create this. I gonna create this compilation. So I have all the questions here lined up already. Already waiting to be used. So calculus. Literally everything here already sorted. Right, so which year you feeling like Mikhail, boy? Which year you feeling like?
And you say I do 12 years of past papers and so
So you good then? I find a decent question for you. Alright, nice. It's a nice question. It's a nice question. Let me tackle this. Alright, so Mikhail, get this question. I'll read from you. Wait, eh?
I
Yeah,
feel
get
like
this
I
question.
say that just now and I'm going to be humble so bad now.
There we go. Yeah, this is hard maths.
The equation of a curve is y equals 3 plus 4x minus x squared. The point P, 3, 6, lies on the curve. Find the equation of the tangent to the curve at P, giving your answer in the form ax plus by plus c equals 0, where a, b, and c are, I don't know what that
Alright. So you see this part over here? This means that it's an element. This means element. Element. And this over here just means integer.
Yes, sir.
What exactly is an integer? An
A whole
integer
number.
is, yeah, not just a whole number. So it would be like negative. I want to do some things with pure maths. I mean pure maths, I want to. So Mikhail, when I tell you that A, B, and C is an element of integers, it means that the value for A, B, and C has to be within its range. Has to be a negative whole number, 0, or a positive whole number. You understand?
Yes, sir.
So if I get A to be a half, that could work?
No, sir.
No, that can't work. So here what? When you read this question, right, Nikolai, I say Nikolai, you're not Nikolai, you're Mikhail. When you read this question, they're giving you the equation of the curve. Let's write that down immediately. The equation we have is y is equal to 3 plus 4x minus x squared. That's a line or that's a curve?
A curve.
A curve. So the gradient will be changing at every single point. So you need to find the gradient what? You need to find the gradient?
Function.
Right, the gradient function. How you do that? How you do that?
Well, first, I would rewrite that in the form ax squared plus bx, right, plus c.
Right.
So we're differentiating.
How to differentiate? Yeah, how to differentiate? Because when you find the first derivative, you're finding the gradient function, correct? And they're telling us you have a point that lies on the curve. You see now a point, you have a point,
Yes, sir.
right? So that's the specific point we are dealing with. I'm just going to do a quick sketch. Since the coefficient of x squared is negative, would this be a maximum or minimum graph?
Maximum.
Be a maximum. It looks something like this, right? So we have a point 3, 6 is a random sketch. I could call this point 3, 6 here.
Yes, sir.
So they are telling us find the equation of the what? Find the equation of the
Tangent.
to the curve at
P.
right. And this point here is 3,
Well,
6 is
the point on the curve.
what is the name of that point? What's the name of that point?
P.
P, right. And they want us to find the equation of the tangent to that point. What would the tangent to this point look like? Would it look like this?
No, so it have one point of intersection, so it'd be a slant negative. Yeah.
So tell me something, Mikhail. Let's run through the concept. We're trying to find the equation of the tangent to that point. That if that's the case, when you find the gradient function, what gradient you have to find at x is equal to what?
Wait, when you find
So, Mikhail, when you have the gradient function,
mm-hmm.
you're trying to find the gradient at what x value?
The given value
Right? So what is the given value for x here?
3, 6.
Nah, 3, 6 is the point. What is the x value?
Oh, 3.
3. So, Mikhail, when you find the gradient function, you need to find the specific gradient at what x value?
3.
Good. You understand?
Yes, sir.
So you'll find the gradient function, and then you'll plug what value for x into the gradient function?
3.
Good. Right. You need to understand the question. So let's find the first derivative first, which is the gradient function. So that'll be the
dy.
change in, right? The dy dx, change in y over change in x. And if I differentiate this normally, what would that be?
Minus 2 x plus 4.
For those of you guys that are confused, when you're differentiating and you have something raised to a power, you pre-multiply. So we have negative x. So you're going to take 2 and multiply that everything by 2. So we minus 2x. Then you take away 1 from the power. 2 minus 1 is 1. Summing to the power 1 is understood. You don't have to write to the power 1. You could just say negative 2x. Then if you differentiate 4x, you're just going to get 4. Because, Mikhail, I think when you look at this, I think you could see that, okay, if I had y is equal to 4x, right? Right, Mikhail? And you could see that the y value changing by 4 times x.
Yes, sir.
So the rate of change is just 4. Just 4. And well, this is a constant. Does a constant ever change?
No.
So the rate of change is
0.
0. So I'll write that. Right, dy dx is equal to minus 2x plus 4. No, Mikhail, we are trying to find the specific gradient at which point, at which x value.
3.
3. Good, good. So what am I going to plug into my gradient function?
When x is 3.
Right? So I'll draw a line here. I say x is equal to 3. And that's going to be equal to minus 2 by
3
plus.
plus 4.
Right. Minus 2 by 3 is?
2.
Right, so I'm the final answer. It wouldn't be 2, it would be negative 2 because minus 2 by 3 is negative
Yeah.
6.
Negative. Yeah.
And this would be and this negative 2 here, what would it represent? Remember, when you find the first derivative, you find it for the what function?
Gradient function.
Right, so this is the gradient function. And it tells you the gradient at the it tells you the gradient at the what? The normal or the tangent?
The tangent.
Good. So the minus 2 is the gradient at x is equal to 3 for the tangent to the normal.
Tangent.
Good. So in other words, the gradient of this tangent here, m, would be equal to?
Minus 2.
Good. You understand that?
Yes, sir.
So here what? We have the gradient and we have a point on the line. Remind me, we're trying to find the equation of the tangent. The tangent is an example of a line. Yeah?
Yes, sir.
It's an example of a line. So we could recall what the equation of a line is. What's the equation of a line?
Y minus y1.
Oh, you're using you're using the slope point form.
It is mx plus c.
Yeah. So let me explain something, right? This is the slope intercept form. That's the slope intercept form, and the form that you just called to me is the slope point form. You know why? We call it these things.
Because we're using points from the slope to calculate it.
Yeah, you're using the point and the slope to do this one. And for this one, you're telling you the slope and the y-intercept.
Yes, sir.
Yeah. And lastly, when talking about lines, the standard form of a line, this is ax plus by plus c is equal to 0. Well, I don't think I'll learn this one so much in school. You learn that one plenty in school or not?
I learned that in lessons with my other teachers. Sir.
Okay. All right. So I would tell you to hey, just use y is equal to mx plus c and done. Just use this one and done, right? It's the easiest one to use. But you should understand that they want the final answer in the standard form. Ax plus by plus c is equal to 0. All right. So here what? To find, well, we have the gradient and we have a point. So all we're missing is the what? Or what are we missing from this?
You have the gradient and you have the point.
Mm-hmm.
The y-intercept.
We're trying to find the y-intercept. So here what? What is the y value for a point on the line?
6.
6. So I'll say 6 is equal to, what's the gradient?
Minus 2.
What's the x value?
3.
And we don't know what the y-intercept is, so we write plus c.
Yeah.
And so minus 2 by 3 is?
Minus 6.
And if you move across the minus 6,
It'll be 0. C equals 0.
Nah. When you move across minus 6, what is it going to
Oh,
turn
it's
to?
plus 6. It'll be 12.
Uh-huh. So C is equal to?
12.
Good. And so the slope, well, we have the slope and we have the y-intercept. So what could we write now?
The slope intercept.
So y would be equal to?
Mx plus c, where m is minus 2 and c is 12. Plus 12.
But is that in the form that they want?
No.
No. They want it in this particular form. So, Mikhail, you could do the question correct. If you don't put it in this form, you're not going to get full marks. So they want it in the form ax plus by plus c is equal to 0. So you need to now move across everything and put it in this form. So tell me, if I move across everything, what would happen?
So it'll be positive 2x. Well, plus y.
And I could just write plus 1y to make it look
Yeah.
explicitly uniform, right? Explicitly uniform. You understand?
Minus 12.
1y, you mean 1y and y mean the same thing, right?
Yeah, the one is understood.
Good. And if you move across the positive 12, it'll turn to?
Negative 12.
Right. Isn't that uniform ax plus by plus c is equal to 0?
Yes, sir.
What is A? A is what?
A is 2.
B is what?
Say that, sir?
What is B?
B is 1.
What's C?
Minus 12.
Good. Are all of them integers?
Yes, sir.
Yeah, because we have positive and negative whole numbers. Now,
sir.
this is the moment of truth. When let me test this out. Let me test it out and see for myself if it's true. Let me see. This is the moment of truth, right? What is my curve? What is my curve? Right? What's the curve? Well, tell me, Michael.
3 plus 4x minus x squared.
What are they, boy? Wait, feel like I didn't press equal, my bad. Yeah, y is equal 3 plus 4x minus x squared. You see the line, right?
Yes, sir.
I don't know why that happened. But what was the equation we find?
2x plus 1y plus y minus 12 equals 0.
Now let me ask that question, right, Mikhail? This line is supposed to be touching the curve at what point?
P
Which is?
3, 6.
You ready for the big reveal?
Yes, sir.
Let me see. Badness. Mathematical badness. There we go. Right? Yeah. Oof. Material cool, like. So anytime you read a question like this, Mikhail, have a way to think. Write down the equation of the curve. Right? Regardless of what you had to do, you need to find the gradient function. But this gradient function will find the gradient of the what? The normal or the tangent?
Tangent.
Tangent. Good. The tangent at a specific value for x. If they give you a yeah, I get insured Wi-Fi. I teach in a class at the camera on. I'll come fix that just now. Yeah. Yeah, so Mikhail, regardless of what happening, you need to find the gradient function. But this gradient function is for the what again?
The tangent.
It's for the tangent. So we do a question just now where is the normal, right? You say we can handle that. They're going to give you a specific point. Now, if you want to find the gradient of the tangent at this point, what do you need to plug in?
The x value.
Good, the x value. because we find the gradient function, and the gradient function would accept different values for x. Good. Once you have the gradient of the tangent, now we could just use y is equal to mx plus c with a point on the line to find for what?
The y-intercept.
Good. And you can write your final equation. But you need to pay attention to what form they want it in. So if you answer that, 2x plus 1y is minus 12 is equal to 0. Yeah. Easy marks or hard?
So your explanation with everything so far since I find your channel was way simpler, and it just way better than all the explanations I've heard so far.
Thank you, thank you. You're experiencing it firsthand. You're experiencing it firsthand. Now I mean?
Yes, sir.
Right, so I'll be back. I'm gonna give you a question in the meantime. Um aha. Fix up. 5 marks. 5 marks. No. Remember, when you find the gradient function, you're finding the gradient of the what?
The tangent.
Not the normal. Not the normal. If you wanted to
sir.
find the gradient of the normal, you'd have to find the what?
Negative reciprocal.
Yes, the negative reciprocal. Remember, we talked about that, Mikhail. We talked about that, right? You know, if you find the gradient of the tangent, then the gradient of the normal would be the
The negative reciprocal.
right. So I told you, regardless of how they bring the question, you need to find the gradient function, and that gradient function will give you the gradient of the tangent. So once you have the gradient of the tangent, Mikhail, you can find the gradient of the
The normal.
by just finding the
The negative reciprocal.
bam. Fix up. I really feel Virginia, is it real
Yes.
good? Is it real good at maths something?
Yeah.
Yeah. It sounds like you have a real strong foundation in maths.
Yes, I do.
And that is the most important thing. A strong foundation is the most important thing. Yeah.
Well, thanks to your help, I'm understanding this easily.
That's good. That's good. That's good. I'll be back. We'll be back, guys.
Okay, bye, sir.
We'll be back shortly, guys. I'll again show the question on that.
Yes, sir.
Yes, sir.
Yeah, this question looks a bit harder, but I promise you it's simple. The equation is just in a form where you can readily differentiate. But for powers of 2, you could always just expand. Once the power is more than 2, you have to use chain rule. Yo, we cooking, we cooking, we cooking. Are we cooking?
I hope
Yes,
so.
sir.
All right. Let me tackle the question, right? So they say we have a point here. All right. Underline that one time. A point. Point is 1, 8. And it's telling us that line on the curve y is equal to 2x by x plus 1 squared. You can't readily differentiate that, eh? I'd say that in big. You cannot readily differentiate that. Unless you use, like, okay, if you want it, you could use the product rule and the chain rule, but I don't recommend doing any of that. And for those of you guys that can see it, this is what kind of curve, quadratic or cubic?
Cubic.
Cubic.
I'm gonna say
Is that-
cubic.
This is a cubic, right? Because if you expand it, you have x plus 1 squared. You end up with a squared term, and then that squared term is going to multiply by x, which is going to give you x to the power 3, which is cubic. Now, generally speaking, a cubic equation could cut the x-axis 3 times, just pointing that out. At most 3 times. But anyways, I'm not confused all you. Yeah, so Mikkel, determine the equation of the what?
The normal.
To the point at point?
P.
Okay, good. So here we're going to do, right, Mikkel? And if we have something to the power 2n, and we could expand that, that's not that bad, right?
Yes, sir.
Yeah. Did you expand it?
Yes, sir.
Okay, good. Right, so we have 2x by x plus 1 squared. Let's quickly expand this. So that's going to be 2x by x plus 1 by x plus 1. If you expand that, you're going to end up with x squared plus 2x plus 1. I don't understand how they want me to do full thing.
Understand.
I understand, sir.
You know what? I have real trust issues, so I'll just do the full thing. I don't understand how much trust issues I have in it. I don't understand. Like, anytime when they tell me all they understand one thing, I just never believe all they.
Wow.
So like x by x. What is x by x?
X
Well,
squared.
that's x squared. X by 1, that is 1x.
X.
Right? 1 by x, that's another 1x. And then we have 1 by 1, which is 1. Yeah, that'll just be x squared plus 2x plus 1. Now, some of you guys may have learned this. If you have something like ax plus b, if you have ax plus b squared, it's just going to be ax squared plus 2, plus 2 what? 2abx plus b squared. I don't know I don't know if any of you guys would ever learn this.
Yes, sir.
Yes, sir.
Yes, sir.
Nah.
Or even simpler, some of you guys would have probably learned x plus a squared. Right? And x plus a squared, that would just be, so think of it visually in your head, right? X by x, okay, x squared. Then you go have x by a, that's 1ax. Then you go say a by x, which is another ax. So you end up with 2ax. And then you do a by a, that'll be a squared.
So I
So
feel that
it's-
it can a little more brain power than the top one.
Both of them real easy. Both of them real easy. But if you forget, just expand the thing now, dog. Just expand the thing. Just expand the thing. All right. Let's expand the brackets now. So we're going to distribute 2x across all the terms in the bracket. So you're going to say 2x by x squared, 2x by 2x, and you're going to say 2x by 1. What's going to happen there?
There you go. You want to expand it out, sir?
Yeah, you had to expand it out. You had to expand it out.
Yeah, so it'll be 2x cubed plus 4x squared plus 2x equals 0.
Where you get that equal to 0 from? That's what I'm wondering. Where you get that equal to 0 from? That's just why. That's just y is equal to that. No 0. No 0, right? Cool. So you guys can see it's a cubic. Let's graph the cubic quickly to see what it looks like. Generally, cubic equations look something like that. Again, like I said, they cut the x-axis at 3 points. Three intercepts. Virginia, you know to factorize an expression and thing?
Yeah.
And if a cubic is factorizable, and generally speaking, you can reduce it to a product of 3 linear factors.
Okay, so I don't know what you just said. I never did a cubic before, but I know it's a factorize in general. But I can try.
Right, you know what a linear factor is?
Not too sure.
Okay, you know what linear means?
Anything referring to a line?
Yeah, so something is linear if the highest power for x is 1,
Oh,
right?
okay.
So like x plus 4 is linear, 5 plus x is linear.
Oh,
So for instance, this x is linear, this x plus 1 is linear, this x plus 1 is linear. So what I'm saying is any cubic could be represented as a product of 3 linear factors. And when you solve for each factor, you realize it can cut the x-axis 3 points at 3 points for the modes.
okay, sir. Thank you.
But anyways, yeah, Mikhail, you seen this what the graph looking like, right? Right, Mikhail? This is what the graph looking like.
Yes, sir.
Right. So like I said, generally speaking, this is what most cubic equations look like. Let me just check something real quick. Oh, let's see that. Mikhail, you see that, right? If I put negative, it kind of switches. Same way like a
Yes.
quadratic. All right, but anyways, I just gonna do a quick sketch so you can kind of visualize what the heck is happening. That's what we have, and you have a point 1, 8. You know what? This is a sketch. It really don't matter. If you want, you could call this what? Call a 1, 8. It's okay.
1,
This is a sketch. This is a sketch, Mikhail. Now, Mikhail, do you understand that the tangent to the point would have been here?
Yes, sir.
But do we want to find the equation of the tangent?
You'll have to find it to find the normal.
Perfect. So you have to find the equation of the normal to find the. You have to find the gradient of the tangent to find the gradient of the.
Normal.
Good. So here we're going to do. And that will be at what x value?
X equals 1.
Perfect. You have everything on that. You have everything locked in, right? So let's find the gradient function quickly by finding the first derivative. So differentiate 2x cubed from 1.
6x squared by 8x plus 2.
If any of you all are confused, when you're differentiating, you're taking the power, you're multiplying it by the coefficient. So 3 by 2 gives us 6. Then you take away 1 from the power. 3 minus 1 is
2.
2. Good. And then 2 by 4 is
8.
8. Minus 1 from the power?
1.
Right, so it's 8x. And if I differentiate 2x, it's just going to be
2.
2. Good. And this is the gradient function. It will give us the gradient of the
Tangent.
tangent. So we want to find the gradient at what point?
At x equals 1.
X is equal to 1. So we're going to plug 1 into this. So that's going to be 6 by 1 squared plus 8 by 1 plus 2. What are we going to get?
Oh wait, so before thing, when we get the function, right? I divide 6x squared plus 8x plus
Nah,
2 by
do that.
do that.
If it was equal to 0, say for instance you're finding the stationary points where the gradient is equal to 0, then you're allowed to do that. Because in that case, Mikhail, there would be no consequences. And let me explain why. If you had something like 6x squared plus 8x plus 2 equal to 0, and you divide it throughout by 2, that's fine. You will get 3x squared plus 4x plus 1. And if you divide 0 by 2, you'll get
0.
there's no consequences there, none.
Yeah,
However,
because
if you divide by 2 throughout, you know what you're gonna find? You're gonna find a half dy dx.
oh,
Because whatever you do on one side will happen to the
other side.
exactly. So you technically be dividing dy dx by yeah. You don't want to do that. Why would you want to do that? You can only do that when it's equal to 0, where it doesn't affect, where it wouldn't affect anything. So that's a mistake there. What is 6 by 1 squared?
6,
Right? 8 by 1 is
8,
right plus 2. What would you get?
16.
16? Yeah. And that would tell me the gradient of the
The
I
tangent.
don't know my colors though. The gradient. I would say the gradient of the green line or the purple line.
The green line.
The green line, right? I looked at that for a second and I was like, what colors is that? Hey, I tell you, when you max out one stats in your life, like all the other stats just fall. Like I just struggle to have regular conversations with people just because I just talk about maths all the time. So this is equal to 16. So Mikel, think about it, right? Think about it, Mikel. If 16 is the gradient of the tangent, what do you suppose the gradient of the normal is?
uh,
So if you're confused, right?
maybe
I could write
1,
16. Wait, I could write 16 as 16 over what?
1,
And so if you change the sign and you flip it, what you go turn to?
negative 1 over 16.
Good, negative 1 over 16. You with me on that?
Yes, sir.
You with me? Okay, good. And so we have the gradient of the normal, and do we have a point that lies on the normal?
Yes, sir.
Remember, the normal and the tangent will pass through the same point, which is
Same point. P.
P. Excellent. So we have a point, and the point is 1, 8, and we have a gradient. We know that the gradient of the normal is minus 1 over 16, and we could fix up.
Yes, sir.
Yeah. In this question, did they want the answer in a specific form?
Sorry, sir. No.
No, they didn't want the answer in a specific form. So here, we could just write the answer in y is equal to mx plus c and tell them take that. So remember, what is y is, I already tell you, right? I already tell you is y is equal to mx plus c.
Yes, sir.
Where's y and where's x?
Where's y? Well, the gradient could be minus 1 over 16. Y could be 8.
X will be 1. Right? So I'm gonna say 8. The gradient is minus 1 over 16. What is x?
1.
Right. What is minus 1 over 16 by 1? Should minus 1 over 16, right? Anything by 1 is the original thing, so that'll be minus 1 over 16.
Yeah.
And I'm trying to find for C. So what will I do if I want to find for C?
You transpose minus 1 over 16.
Hey, when somebody talking, the button, right? But yeah, that's correct. Mikel, you know that, right?
Yes, sir.
Right. So that's gonna be 8 plus 1 over 16. What is 8 plus 1 over 16?
Okay.
I think that's 97 over 16. I'm not sure. Let me check it.
Yo, what the fraction or your one time?
So it's a fraction. No, that'll be 129.
129 over 16.
So what's the equation of the then what's the equation of the normal?
Y equals minus 1 over 16 plus 129 over 16.
Now, here's where the magic is going to happen. Let's see if we are correct. Michael, you trust in any maths?
Yeah, I had to trust it.
Yeah, I trust you, right? Yeah, I trust you, right? Are you trust in any maths?
Yes, sir. Yes, sir.
Yes, sir.
Let me see. So let me try a thing now. Let's try a thing. So we have y is equal to minus 1 divided by 16 x plus 129 all over 16. All right. Does that look like it's tangential? I'm not saying tangential, but I'm saying, I mean, does that look like a normal?
Yes, sir.
When I press that dot, what should I get?
1, 1,
One.
and 8.
Bam, 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 boom. Let me go. Let me go. What are you talking about? Math badness. Math badness. Yeah, boy. See? Badness, badness, badness. Math's real bad and math's real bad. Hey. So we're correct.
So I feel
Yeah,
this
make
is
it.
the least amount of people ever see in one of your class.
I don't know. I never make a video say I was going to do hard maths. And well, um,
That's from the group. Like not much sharing. Let's do admats.
I don't know why, boy. Why people don't do hard maths? Well, to be fair, right? Let's be honest. Let me look at the stats. 62% of the Caribbean fail maths. Do you think they would? Do you think they would do hard maths?
No,
Nah.
sir.
Nah. So like, not much people do hard maths to begin with, all right? But badness though, one maths badness though, maths real bad. Yeah. So Michael, you think you understand how to tackle these normal and tangent equation questions now?
Yes, sir.
Right, guaranteed 4 or 5 marks if it does come.
Yes,
And
sir.
I
I've done a whole set already on like practice.
okay, good. And you guys should be able to handle first principles now. Right? You should. Or just remind me, what does first principle say?
F of x
The
Limit.
or
limit.
limit h tends to 0. F of x plus h minus f of x over h.
Good. Yeah, this is hard maths. Yeah. All right. Cool. Cool. We getting it. We getting it. We are getting it. Nice.
So come on, back, please.
All right, no problem. Virginia, the maths making sense so far?
Yeah, it's making a lot of sense.
Okay. Wait, are you from Trinidad? I hear like a slight accent. I saying a slight accent.
Everybody's telling me that, but I'm actually from Trinidad, so yeah.
Oh yeah. Did you tell me I was from St. Francois Girls? Yeah. I had a student from there. And which I told you, which means you have to be from Trinidad. Yeah.
Yeah. But it doesn't seem that bad. Everyone was saying this was so hard, and it doesn't seem that bad the way you explained it.
Odd maths is the best dog. Odd maths is vibes. Odd maths is vibes though. Because like, yes, see, check this.
Yeah.
We do all of this madness on people, right? We do all of this madness.
Yeah.
And when I plot the thing and I press the dot and watch,
It's proven.
it's
You know?
proven. Badness. It's
Yes.
proven. Yeah, boy.
And I like how you can like actually derive it, but like unlike a bio, you have to know it. And if you don't know, you could.
Exactly. That's how I was be thinking too. Like if you had, I like things where you could figure out. If you can't figure it out and you just had to memorize, and it kind of sucks.
Yeah, I agree.
But you can. I like things where it just relies on your brain as opposed to memorizing.
Yeah.
Yeah. Maths. I like odd maths. Odd maths more straightforward, right? Odd maths more straightforward. It looks scarier, but more straightforward. Because
Yeah.
like, none of that. Like, okay. Let me explain what I mean, right? I'm gonna show you what I mean quickly. You see how maths is beat around the bush and thing? Like a recipe for making 20 bite-sized cookie uses. God. I
I
don't
saw
want.
some cake. Oh my gosh.
Watch. This is easy. It's real easy. It's very easy.
Yeah, I realize it looks really complicated, but it's not that bad.
It's not that bad. Not that bad. All right. So, Mikhail, let me run it thing now. So, Mikhail, you should be able to tackle first principles, normal and tangent questions. Let's look at the rules for. Yeah, I'll be posting this live on YouTube. I'll share this live with your auntie, your uncle, your grandfather, your sister, your brother, everybody now. I find it place dead. 13, 14 people. I don't know what's going on
So
there.
funny enough, while I was answering the question, I was messaging my aunt and tell her she check math pipes on YouTube.
Oh, yeah. I find the place too dead, boy. This is the lowest numbers I've ever seen in a while. I don't know what's going on. Let's stick it on. Let's stick in bad, dog. And then night before, the numbers are gonna be real big, and they're gonna be like, sir, you can do differentiation. I'll be like, where was doing only 13, boy? What you was doing on the 13th? Anyways, let me look at the rules for differentiation. You have some rules to remember. Right, number one.
Sir, check it. Have the rules on my wall already.
Badness. So rules for differentiation. Number one, you have the product rule. Now you typically utilize this rule anytime you have a product of two different functions. And you guys, if any of you are going to do tertiary level maths, like further your math studies, you guys will see that integration by parts is just the reverse of product of two different functions. Mark my words, you remember when you're doing that. Right? So product rule is product of two different functions. Okay, cool. What does it look like? It looks like this. So if you have u by v ddx, then to differentiate this, it's going to be v du dx plus u dv dx. Now, some students learn it a bit different, but I'll explain something just now. So some of you guys might learn it as u dv dx plus v du dx. But does it really matter? Does it really matter?
Yes, sir.
No.
Matter. We teach that way. Matter.
No. Let me ask you that question, right? Where's 1 plus 2?
3.
3.
Where's 2 plus 1?
3.
3.
Does it matter?
Nah, commutative.
Those communicative laws coming in clutch.
Yeah, because addition, my friends, is commutative. Fifth teacher, okay, Michael, I feel like you're confusing this one with quotient rule. Because in quotient rule, it does matter because subtraction is not commutative. I feel like that's what you're tying it up with.
I feel so, sir.
Yeah. I tell students to learn it like this because when you learn it like this and you have to do the quotient rule, you don't mix it up. You can see what I mean. So this is the product rule. Number 2. This over here, this is the quotient rule. What does quotient? Product means multiply. What does quotient mean?
Divide.
Quotient means to divide. That's what it means. So, and it typically uses when you have when you have a, like, you divide into different functions, right? You have a quotient of functions. So, like, I'm gonna show you what I mean. So, like, I say you had u over v, right? ddx. This is the one where the order matters because subtraction is not commutative. So I'll say v du dx minus u dv dx all over what?
V squared.
Yeah, all over v squared. Now, Mikkel, if I decide to catch a VAPS and put u dv dx first, does it mean the same thing?
No, sir.
No, it doesn't. Why? Consider you had 5 minus 7. What's 5 minus 7?
-2.
Okay, what's 7 minus 5?
2.
2. Is it the same thing?
Nope.
No, it is not the same thing. So, Mikkel, that is why it matters in the quotient rule, but it doesn't matter in the product rule. And I think you all would understand why I tell my students to remember V first, right? I tell them to learn V first. You know why? Because if you remember V first in your product rule, I think you're going to remember it's first in the quotient rule as well, right?
Yes, sir.
Yeah. Oh, and by the way, the numbers could be so low as well because I don't have a Form 5 hard maths class. Because of UE and thing, I could not have a Form 5 hard maths class. And like, I just genuinely not get that much people interested in hard maths. But like, I'm hoping after this season, when I tell people I teach hard maths, I get a good amount of hard maths students because I like hard maths more than maths. Yeah. Virginia, don't forget to message me, and I go speak to your parents, and I'll add you.
Okay, sir.
Yeah, I have some other students like you in my art maths class. So I really like art maths, and they're like really proficient in it.
Okay, nice.
Yeah. I seen somebody saying star. Sir, thank you for doing the maths lives. No problem. Big up yourself. Last one we have to look at is the chain rule. When do we use the chain rule, boy? When do we use the chain rule? Well, chain rule is when you have a function and a function. A function within a function. You guys will see what I mean. And you typically use chain rule in connected rates of change. So generally, when you're doing chain rule, let me just say, Mikkel, you there? Yeah, this is on YouTube. This is on YouTube. So Mikkel, you there or nah? Can I hear Mikkel? Xavier, you there? Or Lucas, anybody here or nah?
We hear
Yes,
you,
sir.
sir.
All right,
So,
so Xavier, say you had. Okay, actually, yeah, a quick example, right? I don't know if you ever do this before, but chain rule might look something like this. So dy dx is equal to, it might look like du dx multiplied by dy over what? Xavier, let me show you how easy this is, right? So Xavier, I said chain rule is when you want to connect different rates of change. So Xavier, what do I have to get? What do I have to get?
dy dx.
I have to get dy dx, right? dy dx. Over here, I have du dx, yeah?
Yeah, so it'll be dy over du.
Perfect. Be dy over du. Because you want to connect the rates of change. So this rate of change would be equivalent to the product of these two rates of change. Hence, I'm connecting the different rates of change. Because you understand y is changing with respect to x here. Over here, u is changing with respect to x. So that's a different rate of change. And over here, y is changing with respect to Thomas
You.
Xavier. Exactly. So can you understand that these two are different rates of change, but I'm connecting them to dy dx using a chain rule?
Yeah, I understand.
Nice. So please remember this. These are the rules for differentiation. Have this locked in. Yes, somebody said, sir, do you have to use chain rule for connected rates of change? Yeah. Yeah, you have to use the chain rule for that. That's why it's utilized. And typically use the chain rule when you have a function within a function. So you could do trig graph transformations. I will do that in another session. First principles, I looked at it in extreme detail at the start of the video. Just go back and watch the start of the video. Okay. Everybody have this unlocked, right?
I hope so.
Yes,
Okay,
sir.
take a screenshot if you need to. We're gonna do a bunch of questions now. I feel so bad for the people that are on this live because if they had come to this live, they'd never have trouble with differentiation again. Low key. You know where everybody be.
Yes, sir. Feeling locked in, although it's my first time.
That's good.
Yeah,
That's
sir,
good.
I could do some touching up in this.
All right. Well, let me run it now. All right. How Avengers assemble. Wait a All right. Let me continue. So, well, give me a random year. I have all the past papers sorted in years. So, like, what year do you want to look at? Give me a year. Pick a year. Pick a year, chat. Hey, Romano, good
2024.
night. Wait, which year?
17.
17? Okay. Aha. Aha. Okay. Let me tackle this now. So let me give all some pointers as to when to use chain rule now. So let me give all some examples of when you would have to use it. Say I had something like, right? Say I had something like sine 5x, wait, say I had a function like f of x is equal to sine 5x. Or say I had a function like x plus 1 to the power 7. Let me ask you a question, right? If you had to differentiate x plus 1 to the power 7, are you going to multiply that by itself 7 times and then simplify?
No, sir.
No. Are you going to do that?
That seems time consuming.
No, we're not going to do that, right? We're not going to do that. What we are going to do, though, we're going to let x plus 1 be a separate function. So you might say let u be equal to x plus 1. And if you say u is equal to x plus 1, it becomes the whole thing. And I hope I know f of x means y, right? I hope I know that f of x means y.
Yes.
That whole thing would just become y is equal to u to the power 7. So can you see that we've represented f of x as a function within a function? If you can't see it, that's fine. I said f of x, which is y, was equal to u to the power 7, where u was a separate function. But anyways, can you guys see that we now have two different equations?
Yes, sir.
Are you seeing it or no? Xavier, Mikhail, Lucas, can you guys see we now have two different equations?
Yes, sir.
We now have two different equations. So you will have to use chain rule to connect the different rates of change to get back dy dx. So I hope it makes sense. Hey Christopher, where's the plan? Big up Chris from Adaptation one time. Big up your whole self. Don't worry, I'll explain chain rule in more detail. So typically speaking, you have to use chain rule for these types of questions where you have a function within a function, and it's really tough to work with. Okay, so guys, you know what? I feel like I should look at chain rule separately. I think you guys will have no problem with product and quotient. Really simple, but chain rule might give you all some trouble. So I think we should look at that first. What do you think?
Okay, sir.
Okay.
What do you think? I just asking all. Which one I want to look at first? Product, quotient, or chain?
The easiest one first, so I guess product.
Products? How about the rest of you guys?
Yeah, product.
Yes, sir,
Product.
brother.
They don't want to do a chain rule. Oh, okay.
Save the best for last.
Save the best for last. No problem. All right. Let me tackle that then. Product rule questions. I'm trying to do as much possible questions as possible. But I wanna explain something, right? The reason why chain rule is so important is because in these questions you typically see product rule and chain rule questions combined. Because I don't know if you all realize, but you have 2x multiplied by 4 minus 8x to what power? Square root to the power what?
Ah.
A half.
Negative a half.
Half. Not a negative, a half. So like I hope all they see we have a product of this by a product of this. But this over here is chain rule. So you typically see them combining product and chain rule. You generally have to use chain rule anytime like something is weird. So like if you see a function like f of x is equal to the square root of x plus 5, you can't differentiate that conventionally speaking. So you'll have to say x plus 5. You'll have to write it as x plus 5 to the power half and then use chain rule. So all these are questions that you might have to use chain rule for. The chain rule is very, very important. But let me look for a product rule question since you guys asked for it. Like watch. Watch. Over here, this is an example of a product rule question, right? But we had to use for sine 5x. We had to use for sine 5x.
Chain.
She's always product and chain. Can I find a product rule question by itself? I'm not really seeing that, I guess I could just come up with one. You guys need to know some basics, right? Before we do anything, you gotta know the basics. Yeah, I don't know the basics. They run through the basics real fast. Remind me, if I'm finding the derivative of of ax to the power n, what would that be?
A N X.
I would say a n x to the power n minus 1. We saw how this worked at the start of class by using first principles. Now we're going to look at what is the first derivative of a constant?
1.
0.
0, right?
Oh,
Constant is 0. What is the derivative of ax?
A.
A. Yeah, that's just a, right? That's just a. Yeah, so here what? I'll show you guys the full chain rule and then the shortcut of the chain rule. But let's go through some more basics. The first derivative of sine x. Do you all know what the first derivative of sine x is?
Minus
Cosine
cos x.
Yeah, minus cosine x. You sure? You sure it's minus cosine x?
yes,
I don't think it's minus cosine x.
Sine x cosine.
It's cosine x. Hey Christopher, but you're not real like the start of this class because I showed them, like at the start of the class, I showed them the concept of differentiation as well as why you need to come up with a gradient function and how to come up with a gradient function using first principles. Yeah, you're not real like the start of this class. You're not real like it. If I don't know who Chris is, good night, good night. If you don't know who Chris is a goat, you know, dog. That's Chris from adaptation. He real go to the maths. He real go to the maths. And hard maths, of course. Yeah. Another basic you need to know is the derivative of cosine x. What's the derivative of cosine x?
Minus sine x.
Minus sine x. I know it's a bit funky. Yeah. It's minus sine x. So the derivative of sine x is cosine x. And the derivative of cosine x is minus sine x. What else do you guys need to know, boy? I feel like we could roll here. Yeah, I feel like we could roll here. Take a screenshot of this. Yeah. All right, let me do a question now.
So this is what admans look like.
Yeah, these are maths. These are maths. I had a parallel highly, otherwise go to live studio. Oh, that is why TikTok was banned, no? Oh, because I was inactive. What they expect me to do when I'm teaching, boy? What TikTok expect me to do when I'm teaching, all that? TikTok. Right. Let me look at the
So
product
they want you to
rules.
be interactive.
Yeah. Big up Sarah one time. Sarah, you might be a future teacher at Math Vibes Academy. You know what I mean?
Thank you, sir. Sir, I hope these children willing though.
Say that again.
I hope these children willing to listen though.
These children, oh nah, they'll be willing to listen, right? Be willing to listen. Say we had 5 minus 8x by sine x. When you look at this problem, guys, can you guys see that we have a linear function over here and a trigonometric function here, and we're multiplying them?
Yes, sir.
Yes, sir.
Right. Anytime you have a product of two different functions or a product in general, you could use product rule. So I would say that this is u, and I would say that this is
V.
yeah, that's u and that's v. Mikhail, remind me, how do I differentiate a product of two functions?
V by du dx plus u dv dx.
Good. So for me to differentiate this, I would need to know du dx and dv dx. So what is u equal to?
5 minus 8x.
Okay, and what would v be equal to?
Sine
V would
x.
be sine x. Correct. And so what would du dx be? We have to find du dx.
-8.
Yeah, du dx would be -8. And what would dv dx be?
Cos x.
Remind me. Right. When you differentiate sine x, you get
Cos x.
cos x. I want to do a pure maths live a day, I want to run that today. Are you know one? Yeah. Yeah, buddy. But I don't know if anybody go join though. If it have like such a scarce crowd for hard maths, I don't know if anybody go join for pure maths.
Sorry,
You
I
know?
would join.
Sir, I'm planning to do pure math in Form 6. I'll join that.
Okay, bet. So let me find the thing now. So if I wanted to find ddx of 5 minus 8x by sine x, it is going to be u, once again, it's going to be v by du dx. What was v? Somebody remind me, what is v?
Sine x.
Right, v is sine x. That's what v is. And we're going to multiply that by du dx. What is du dx?
Cos x.
Nah,
No, minus
Oh,
8.
-8, sorry.
right? -8.
But sir,
Yeah?
how do you get -8? Did you just take off the 5 and x? I'm confused.
Okay, no problem. So Virginia, so when you're differentiating, you differentiate each term, right?
Yes, sir.
This might confuse some people, but generally speaking, differentiation is like a linear process
Oh, okay.
because we apply differentiation to each term separately. But let me explain something. 5 is a constant, yeah? 5 is a constant.
Yes, sir.
Will 5 ever change?
No, sir.
No, so the rate of changes,
Constant? The same?
if it, 0.
Oh, 0.
Yeah.
Oh, sorry.
Because it doesn't change, right? It doesn't change. If something doesn't change, it's going to be 0. There's no rate of change, 0. So
Okay,
I just, instead of, I forget about the 5. If you differentiate that constant, it's going to be 0. And you have -8x. If you differentiate something in the form ax, it's just going to be a. So if you differentiate -8x, it's just going to be -8.
Oh, I see. Thank you so much, sir.
Let me explain something, right? Let me explain something in a way that you'll actually understand.
Okay.
Consider you had a function y is equal to 5x. Let's input a couple values for x now. So I would just say x is equal to 1, x is equal to 2, yada, yada, yada. If I plug in 1 into that function, it's going to be 10. If I plug in 2 into that function, sorry about that. If I put 2 into the function, it's going to be 10. So generally speaking here, Virginia,
Yes, sir.
as x increases by 1, the y value increases by
2. No? 5? Sorry.
5. Yeah, that's okay, by 5. And so, how does y change with respect to x?
As x increases by 1, y would always increase by 5?
Exactly. And so the gradient is 5 over 1, which is 5.
Oh, okay.
Yeah,
Okay, I
so
think
if you have something in the form y is equal to 5x, then it's very clear. It's very clear as to what is the rate of change. Rate of change is just 5 because
okay.
you're multiplying x by 5.
All right. I think I understand. Thank you so much, sir.
I appreciate you, sir, for all you do and for your patience and for putting awareness on the struggle. No problem, no problem. Yeah, a lot of people just say maths real easy, and that's really not true. That really kind of unfair to most of the Caribbean, right? Most of the Caribbean. If you understand maths, that's fine, but most people don't understand maths, which is sad, right? Yeah. So Virginia, what is u? What is u?
U is 5 minus 8x.
And somebody tell me what is dvdx?
Cos x.
Okay, good. Are you understand that or no?
Yes, sir, I understand.
What about Mikhail, Lucas, Xavier, Sarah? Oh, Sarah, you
Yep.
got.
Sure, just here for the vibes. Just know how
Yeah,
I'm
I'm
gonna have to
good.
do IT.
Oh, okay. Yeah. Have a good evening, Christopher. Chris. Here what, right? Go on my let me just put my number in the chat. On YouTube, I can put my number. Just message me. Have a parents and a voice notes are gonna be serious and audio. Right? Cool. So if you expand this, it's going to be minus 8 sine x. And if you expand this, you multiply each term by cosine x, what are you going to get? Somebody tell me.
Five cos x minus 8x cos x.
Yeah, that's it. You don't have any like terms, so you can't simplify. So that's it. That was hard or that was easy?
Nah, that was easy. I didn't expect it. I didn't expect that to be the end.
Yeah, it's easy. It's easy. Text me back again as we get like 100 messages every single day, so we kind of buried. Everybody okay with product rule? Yes or no?
I think so.
A lot of people in the Zoom meeting, all you understand or not? Product rule.
Yes, sir.
Yes,
I
sir.
get sir.
So you just had to identify what u and v are. You have to find du dx, you have to find dv dx, and then put it back into the product rule form, which is v du dx plus u dv dx. Let's do quotient rule now. Again, when product rule does come, it typically comes interlinked with chain rule. So if product rule was a product of two functions, then quotient rule will be a what of two functions?
Quotient of two functions.
Correct. So we are sticking with doing passive questions one time. All right, so Mikkel, I'll wait to help me with this one, right? Mikkel, are you with me or no?
Yes, sir. Yes, sir.
Well, let me tackle this fast. So Mikkel, could you identify what u and v is for this?
3x plus 4 is u, and x minus 2 is v.
X minus 2 is v. I do an add maths live every day till the exam or later. Every single day till the exam. Right? U is equal to 3x plus 4. And v is equal to?
X minus 2.
Good. So what do you think we'll have to find here?
du, dx, and dv, dx.
Right. Because we are differentiating the function u with respect to the variable x. So we'll say du dx. And so du dx is going to be 3. Virginia, you understand or no?
Yes, sir, I understand from what you told me the last time. The constant would cancel and the variable.
And this would just be 3. Because, if I wrote 3x as a separate function, I say y is equal to 3x, you'll see that y changes by 3 times x. So it's just 3.
Oh, okay. Thank you, sir.
No problem. And this is going to be what here? We're differentiating v with respect to what?
X.
X. Yeah, watch. Virginia, we have a function here for v in terms of what?
X minus 2?
X, just x. You tell me the variable, because x is the only thing that's changing here. You could put in any value for x here. X is changing.
Oh, okay.
Minus 2 is a constant. That wouldn't change.
All right, I understand.
So v is changing with respect to x. So just I say dv dx, because hence I could put different values for x into this function.
Yes, sir.
And when I do that, what will change? Will the minus 2 change or will the v change?
Only v would change.
Exactly. So v is going to change with respect to
X.
because when you plug different values for x in, what's going to change?
V would change.
Good. And so the vdx here is just what? What's the vdx, guys?
X?
Nah. You're
1.
not seeing it, right? But what was in front of x? You're not seeing it, but what's in front of x?
Oh, 1.
1. Right? So the vdx is 1. By the way, if any others do TikTok and thing, or like since I'm teaching right now, or they can make a video saying if you want free add maths lessons before the exam, check Math Vibes, Take a look at that for me, because I can't make a TikTok video right now. Finally, let's do TikTok and thing. Because I'm gonna be doing lives every day till the exam. Alright, and I go tag me.
My TikTok vids don't do good now. So
When they hear the Math Vibes, they might
all right.
yeah. Be like Math Vibes gonna be doing free add maths sessions every day till the exam for free. Check him. Again, I'll try to do a little pure maths. Right? If you are Unit 1 pure maths student, these sessions could low-key benefit you. Yeah. All right. So, Mikhail, if we're dealing with a quotient, it'll be UV, U over V dx, and that'll be what again? Time of fast.
V by du dx minus U by dv dx.
All over.
V squared.
And V was V.
V is x minus 2.
If you're confused,
By
remember
3.
we said V was x minus 2. What's the U dx?
3.
What is U?
U is 3x plus 4.
Do I leave out brackets or do I have to put brackets?
You have to put brackets.
I have to put brackets because U is a binomial term and you'll have to apply the minus to all the terms inside the brackets.
Yeah.
Good. I feel so free, like, you know how in maths I try to explain everything like to extreme degree every single time? Like, generally speaking, the ad math students kind of understand the fundamentals to some extent already. So I could speak my fancy lingo and thing. Yeah.
Yes, sir.
Yeah, so dvdx is what? What's dvdx?
1.
dvdx is 1, bam. And I'm going to be over v squared, right? V is x
Yeah.
minus 2, so I'm going to say x minus 2 squared. I'll just say this. Typically, with these types of questions, you don't have to expand the denominator, right? You do have to expand the denominator. Just saying that. So on top, you could expand. If you expand quickly, what would you get?
3x by minus 6.
3x minus 6. And if you hear this earlier, hear this. You have 3x plus 4 by 1. Where's 3x plus 4 by 1?
That's 3x plus 4.
Just 3x plus 4. So we could just distribute the negative term across all the terms here. So what's negative by 3x?
Negative 3x minus 4.
And it's up to you if you want to simplify this, but you can leave it as x minus 2 squared. That's fine. On top, if we simplify on top, what's going to happen?
That'll be the 3x and 3x will cancel. Minus 6 minus 4 is minus 10 over. Yeah.
Well, I want to expand, I'll leave it like that. What do I want to do?
Yeah, just leave it like that. So I just leave it like that.
All right, no problem. But if you did want to expand that, that'll just be x squared minus 4x plus 4, right? Or you know that, right?
Yes, sir.
Yes, sir.
Yeah. That's it. All right, and that would have been the derivative. You would say 3x plus 4 all over x minus 2 dx. Yeah. You okay with this or not?
Yes, sir. You're good.
Yes, sir.
So I wouldn't say this is hard, chat. I wouldn't say this is hard. I would not say it's hard. Product and quotient are easy. You just need to identify what is U and what is V. For our quotient, the numerator is going to be U and the denominator is going to be V. For product, the first term is going to be U and the second term is going to be V. So I hope you guys understand that.
So isn't there a statement it is right to identify it? So for this one, 3x plus 4 over x minus 2 is of the form U over V.
You know how to do that. When you write this, it's understood.
Okay.
So like, you don't have to do that. So like, you could see is U over V. And so if you want to, so then you write U over V dx and you write the formula. And so, yeah, it's fine. This is fine.
Yes, sir.
Let's look at chain rule. Since I was forgetting about it. Chain rule. Real hate for chain rule, boy. W in the chat for chain rule. Chain rule. Let me start off real simple. So if I tell you y is equal to sine 5x. Okay. This is not something you typically will be able to differentiate. You know how to differentiate sine x though. If I differentiate sine x, what would I
Minus
get?
constant.
Everybody understands that? Let me just check something real quick. Oh yeah, yeah. I should say this, eh? One thing. Yeah. Typically speaking, you should say, but like I see it being the same though. Wait, this over here, it's supposed to be ddx, eh? And like generally speaking, when you're writing these things, it should be fine either way, you know. It should be fine either way. Let me just verify something. But it should be fine either way. Because I've seen it. Yeah, well, here what? When you're writing these types of functions, put the ddx first. Yeah, do that. Yeah, I don't know why I put it after. Like, watch. In all of these examples, why I put the ddx, boy?
First.
Yeah, I don't know why my brain glitch like that, boy. Yeah. So the ddx supposed to come first. Yeah, because I was looking at that and I was like, wait now, something sus. Yeah, ddx supposed to come first. Sorry about that. Remember that, right? ddx, because you're finding the derivative of the function. And so, yeah, same thing here. It's just the proper way to write it. The steps are the same, but it's just the proper way to write it. You put ddx first, because you're differentiating the function with respect to x.
Okay, thank you, sir.
Yeah. Ollie, if something not looking right, double check it, sir. Take that advice from me. If something isn't looking the way it should look, double check it. All right, so yeah, how would I differentiate? How would I differentiate sine x? Somebody tell me. How would I differentiate sine x?
Wouldn't it just be cosine x?
Ollie, I agree. Cosine x. Yeah, people. Cosine x.
Yeah, sir.
Yeah, cosine x, right? People on TikTok, YouTube, if I differentiate sine x, what that'll be? Cosine x, right? Cosine x. But how would you differentiate this? That's the question. Well, to differentiate something like this, here we're going to do, right? You see how we have 5x being plugged into sine? I don't know if I've seen it, right? But isn't okay. Sine x, isn't that a trig function?
Yes, sir.
And I could put something e into the function.
Yeah.
Yeah, and I'm putting what into the function?
5x.
5x. So you have a function within a function. You have to use chain rules. Here's what we're gonna do. We're gonna say let u be equal to what?
5x.
5x to simplify things. And if that's the case, then y now becomes what?
Different y.
Yeah, y is going to be sine what? I told you that u is equal to 5x. So what would y be equal to? Y is equal to sine what?
U?
Yeah, sine u. Guys, didn't I tell you guys from the start that 5x is u? So if I told you that 5x is u, instead of writing 5x, what could you write instead?
U?
Yeah, because I told you guys that u was equal to 5x. So now we have two different rates of change, where we can find for two different rates of change and then connect it back using the chain rule. So I'm going to differentiate what with respect to what here,
U with respect to x.
right? Is that something we could readily differentiate?
Yeah, it'd be 5.
That'll just be 5, right? Over here, I'm going to differentiate what with respect to what?
Y with respect to u.
U, yes. Because I have a function y in terms of u. So if I differentiate sine u, what would I get? You guys know this.
Sine.
Cosine u?
Cosine
Of
u,
course,
yes.
yeah.
Yeah, remind me, guys, if I differentiate sine x, what would you get?
Cosine x.
So if I differentiate sine alpha, what do you think that will be?
Cosine alpha.
Yeah, nothing is changing, no, nothing is changing. It's just a different variable. It's just a different variable. That's all. Mikkel, if I say sine of Bob, until I know Bob the fat man. I remember the fat man Bob. Mikkel, if I say sine of fat man Bob, what that will be if I differentiate it?
Cosine of Bob.
Exactly. Yeah, boy. If I don't really law, Bob does be exercising using the vector questions now. Or he eats some KFC again and he get fat again. That will happen. Right?
Oh,
Yeah. So here what I was saying, right? You have two different rates of change, but we need to connect it because at the start of the question, we had y in terms of x. So if you differentiate this function, it's going to give you what? D what over d what?
dy over dx.
Exactly, dy over dx. I'm not sure if you guys are seeing that, but in this equation, we have y in terms of x, where x is the input. And so y is going to change with respect to x. That's what we want to find initially. Now, we have two different rates of change here. You have two different rates of change here. So now we need to connect it using a chain rule. So what would I do with the two different rates of changes to get dy dx back?
multiply.
I multiply. I'm not sure if you all have seen it, but what is du dx by dy dx? I'm not saying dy du. What would this be?
dy dx.
Exactly, because you can think of the du's as if they were
You cancel them out.
good. I'm not sure if you all are seeing it. But what will happen here?
Oh, I see.
What will happen here earlier? What how many du's?
They cancel.
They'll cancel off, and I'll leave you with what?
dy over dx.
Yeah, right. So what is du dx? What do we find du dx to be?
5
What was dy du?
cosine u.
But our final answer must be the derivative of y in terms of x. So can I leave my answer in terms of u?
No, sir.
No, I need. What did I say u was?
5x.
5x.
That's your answer. 5 cosine 5x. That's it.
Oh,
Now here's the hack, right? Here's the hack for chain rule. I'm not sure if you guys realize this, but isn't this just the derivative of 5x, which is 5, the derivative of sine, which is cosine, and I write back what was on the inside?
oh
Yes,
wow.
I'm now going to ask you if you could have just write it over like that. But then if
Yeah.
it depending on the amount of marks, then you would have to do the full working.
Right. If it's a standalone question, so if CSEC asks you to find the derivative of sine 5x and you see a little 4 marks, are you going to just write 5 cosine 5x?
Nah.
No.
Nah. You need to show the full working with chain rule. You need to. So I hope you guys understand that. Yeah. So let me give you all a question to do now. But let me just write down the hack, right? Hack. So if I have something like sine f of x, then this is the hack, right? The hack is just going to be f prime x. You know what? I'll make it even simpler for them. Even simpler, right? Even simpler. Real simple. If I have to differentiate sine ax, I will differentiate ax. If you differentiate ax, what are you going to get?
A.
A sine
If
ax.
I differentiate sine, what am I going to get?
Cos.
Cosine.
Cos.
Oh.
All right.
Yeah.
And I will write back what was on the inside. That's all.
I keep forgetting you had to change that.
Yeah, you have to. And interesting question. If I had cosine ax now, same process. If I differentiate ax, what would I get?
A.
A. If you differentiate cosine, what you get?
Minus sine.
Right? Minus sine, and I write back the ax. And so that will work out to be minus a sine ax. Easy hack. Right? Are you understand the hack one now?
Yes.
Yes.
All you're gonna do, you're gonna differentiate the inside, right on the outside, then differentiate the trig, and write back to you what was on the inside. Somebody say, what are you gonna do with this after life, sir? Well, if you are going to be doing engineering, like let me give you a practical example of this, right? Because all it is always come on and ask them, what we're gonna do is we're gonna use this. If you're an engineer, you're gonna use this stuff all the time in your life, like all the time. I mean, probably wouldn't be all the time, because you could just model stuff using like I can just ask ChatGPT. But generally speaking, there's use cases for this a lot. Like there's a lot of use cases. If you're gonna do something like engineering or architecture or civil engineering, a lot of use cases. You just can't see it, but the use cases are there, right? Obviously, there would be no point in learning it, right? If there was no use cases, why would you be learning it? So don't think like that. There is a use case. It's just hard to see the use case. Yeah, I will be doing things in physics, don't worry. So here what? I'm gonna give all that question to handle for me, right?
Okay, sir.
Try this one. So if you want, you could use the hack to quickly get your answer, right? But I'm giving you all 3 minutes. Go. Mash it up, mash it up. So I hope you all understand. If they ask you for a question by itself, full working using a chain rule. I don't know if I know about this, but I know about honey roasted cashew nuts.
Yes, sir.
That
Yeah,
is
you
real
want to just
slap.
buy on High Street, sir?
Now, yeah, you can buy it on High Street, but it's out in the Go Street. That is real slap.
Nah, so the one on High Street, there's that lash different.
Yeah, boy. Or the one from the hospital. Yeah, in the hospital, is have a nuts, man, all the time. Hey, Adrian Brown, big up yourself. I'm not sure if you're the guy I spoke to on WhatsApp, but if you are, big up yourself. I see you delete the answer. But your answer look correct. Oh, no, your answer not correct. You have to multiply. I see you say, no, check back your answer. Right? Hey, look, Nisha joined. Nisha, what's the plan? Yeah, Adrian, that's correct. Good luck for Nisha. You have it. Hey, big up yourself, Adrian. Big up yourself. I remember you. Yeah, let make all the videos saying that's doing lives every single day till the exam now. You can tag me in it, right? I'll make one myself. Well, you spread the word, spread the word. Too much. If we want, if we want to make the Caribbean a better place, I can't do it myself. All you had to do it as well. All you had to push the narrative, all right?
Like the saying goes, sir, match vibes to the world.
Right, Matt. I've seen you back. Can't do that myself. I need all it to push it, push it.
Yes, I'll finish it.
Right. Oh yeah. So for those that don't know, Sarah is a real good math student. And I think Sarah could get this question. She just should do hard maths, right? She just do maths. I think Sarah could do it.
Yes, sir.
Yes, sir.
Let me check Sarah now. Sarah,
Um, guys, I'm struggling to do IT. I think y'all have too much faith in me to do a hard math question.
Nah, she can do
Add
this. She can do this.
method.
You can do this real fast. So, Sarah,
Yes,
you see,
sir.
you see this 2x over here? See that 2x over there?
Mhm.
A real
Mhm.
problem. A real problem. So you know what we could say? We could say let u be equal to what? Says it,
Minus 7 sin 2x.
nah, the 2x is what causing the problem. The 2x is what causing the problem. The 2x is what
Okay.
causing the problem. So we could potentially simplify it by saying u is equal to,
Minus sin. Minus 7 sin.
nah, the 2x. Because the 2x is what causing the problem there, you know. The 2x is what causing the problem there.
So you want to
And
like you want to put it aside then. That's what you're trying to say.
I trying to, let me explain something, right, Sarah? We know how to differentiate something in the form sin x, right? If you differentiate sin x, you're gonna get cosine x.
Mm-hmm.
So, but is it just x over here or is it 2x?
2x.
Yeah, so we can't work with that. So we're trying to, but if I tell you u is 2x, right? And instead of writing 2x, you can write sine u.
Mm-hmm.
What do you think the derivative of sine u is?
So what do you mean by the derivative, like the
Oh,
number?
this is the derivative. This is the derivative. So the derivative of sine x is cosine x. So what do you think the derivative of sine u is?
U over ux.
Nah, right here. Sine x is equal to cosine x.
Cos x.
So sine u would be equal to what?
Cos u.
Yeah, big up yourself. But you could only do that if you only have, if you see how we have 2x here, that 2x causing problems. So we let it just be
Mm-hmm.
equal to u and we put it aside for now. So Sarah,
Okay.
if I say that u is 2x, then what would y now become?
Minus 7 sin. I want to divide
I know, you know what I'm thinking.
by
What did we
u
say 2x
minus
was?
7 sin u.
Yes, minus 7 sin u. Good. So now we have a function here, u, in terms of x. So I'll say the change in u over the change in what?
The change in u over the change in x or d.
Yes. Because Sarah,
Oh,
imagine you're doing regular maths, right? Remember, a
uh-huh.
function is taking an input and it gives you a
Output.
right. So if we plug different values for x into the function, until you get different values for u.
Yeah.
Yeah, so really u changing with respect to,
No.
you understand? Hey, if I put 1 into the function, I'll get u is equal to 2. If I put 2 into
Yeah.
the function, I'll get u is equal to 4. If I put 3 into the function, I'll get u is equal to 6. So u
Mm-hmm.
changing with respect to what?
The result.
Well, really, u is changing with respect to x. Because if I plug in different values for x, I get different values for y. For you, you see that?
Yeah, I am seeing that.
When I plug in one, what I get?
When you plug in 1, you'll get 2. When you plug in 2, you'll get 4. When you plug in 3, you'll get 6. So basically, it's kind of like what we do in functions, but in a different way.
Yeah. So you can see u is changing with respect to x. The different values for x you plug in, you'll get different values for u.
Mm-hmm.
And so it's changing by 2 times.
Yeah.
This one you might have a hard time with. It's going to be dy du. Forget about the minus 7 for now. That's a constant. Just tell me, if I
Mm-hmm.
differentiate sine, what I'll get? Sine u.
Cos u?
Cosine u. Yeah. And now, the original question was y in terms of what?
At minus 7 sin 2x.
What was the variable in the question?
2x.
X. X was the variable.
X.
So we wanted to find for dy dx. But we don't have dy dx. So let me show you what we could do, right? What if I told you we can multiply two things to get back dy dx.
E and Y.
Well, let me show you. What's gonna happen when the du's?
I
So I'm
think
gonna
in
start. We're
cross
going to the du's.
multiply. I think in you go
Nah, you know.
cross multiply and you go squared.
Nah. Okay, if you had 4/3
Oh, they cancel
by 5/4. Yeah, they will cancel off to leave you with just what?
dx dy.
dy dx. Yeah. Yeah, you see. Badness, right?
Yeah. Come
Yeah.
on, big up to your admath students. I barely understanding this. I barely get in by though. But big up to y'all who doing admath exam tomorrow.
She
Die.
just saying that. But if you were an admat student, you'd be a really good admat student. Right? So yeah. Back to the admat students. So Mikkel, where's the UDX?
du dx is 2.
Right? What is dy du?
Minus 7 cos u.
Uh-huh. Hey, big up, Zaid, right? Big up. Yeah. How much is better? Okay.
Minus 14 cos u.
But our original equation was y in terms of x. Change in y over change in x. So we have to recall what we said u was. What was u?
2x.
Mm-hmm. So instead of saying minus 14 cos u, I'm going to say minus 14 cosine what?
Cos 2x.
That is all. Mikhail, easy marks or hard marks?
Easy. So what? She said that AdMax exam was tomorrow, and that's what your timetable. I was like, it is really tomorrow, but no, it's the when is AdMax? AdMax is the 18th.
Hey, why? Me don't know y'all have admath now. I just joined to support.
Yeah,
I
my hat
have
skip a
IT.
beat. I was like tomorrow.
Sarah, just joined. Sarah, just joined the support boy. Big up, Sarah. But yeah, Mikhail, yeah, time. I think the exam's on the 18th.
Our physics,
Yeah, time.
same week too.
Right. And yeah, all right. And Mikhail, if you was using the shortcut, right? It's shortcut. Wouldn't that just be minus 7 by 2 is minus 14? Sine will turn to cosine 2x.
Yeah, so I done it like that. Yeah, that's multiply. And yeah.
But Mikhail, if you see a format question and they just ask you this, where you can figure it out?
Nah, sir. As I
No,
go
you
to
can't
the
do
check
that.
your answer.
Mm-hmm. All right, next one. Would
I was
you
thinking I party it
wait
out
there?
now.
Would you multiply 7 minus x by itself 9 times?
Nah, sir.
Nah.
No. I'm sure. Wait there. Ethan. Yeah. My question, right? If we had something like y is equal to x to the power 9, would that be easy to differentiate?
I don't know.
Yeah.
Yeah, so Virginia, when you're differentiating, you're taking the power, you're multiplying it by the number in front, you're minusing 1 from the power. So Virginia, yes, this would be easy to differentiate because it would be 9x to what power?
Oh, to the power of 8.
That really easy, right?
Yeah.
Now that is x to the power 9, but guys, we have 7 minus x to the power 9. So what causing the trouble there? What causing the trouble?
The binomial, the bracket.
Yeah, the 7 minus x. So again, watch here. What was causing the trouble here?
Oh, the 5x.
So we just say let it be equal to?
U?
Yeah, so we could simplify it. So we're gonna say let u be equal to.
7 minus x.
7 minus x.
Because he causing trouble. He causing trouble, dog. He causing trouble. Right? And so y will become what now? Wait, let Virginia answer. So Virginia, what I said 7 minus x was causing some trouble. So I
Yeah.
said let u be equal to 7 minus x. So instead
Oh,
of writing 7 minus x, we could write
oh, y would be equal to u.
u to what power?
U to the power of 9.
Right. Are these things you could easily differentiate?
Yes.
Yeah. Over here, I'm differentiating what with respect to what?
7. U with respect to x.
Yeah. If I differentiate 7, now I just into what?
Um.
Is that constant? Anytime you differentiate that constant, what that'll be?
Oh, so it'd be minus 1, minus 1.
If minus 1 is the answer, yes. People are telling me minus 7x. Minus 7x is wrong. Mikkel, no, you're not seeing it right, but what is the number in front understood to be in front of x?
1.
Yeah, that's really minus 1x. And if I differentiate minus 1x, that's just going to be
Minus 1.
just minus 1. Just minus 1. Yeah. Here's another example if you're having a hard time with it. If you differentiate minus 5x, what do you think the answer will be?
Your answer.
Minus
So
5.
Yeah, minus 5. If I differentiate 9x squared minus 8x, what that will be? Somebody tell me fast with speed, with gas.
18x minus 8.
Yeah. If I differentiate minus x, what that will be? Tell me, Virginia.
Minus 1.
Right, because it is understood to be minus 1x. If I have minus 25x, what that will be? Somebody tell me fast.
Minus 25.
Right. I think we're okay with this now. Are you okay with it?
Yes.
Yes.
Sir.
Sir.
Okay, cool. And over here, I'm differentiating what with respect to what?
Y with respect to u.
Yeah, I'm differentiating y with respect to u. And so I'm going to pre-multiply. So that's going to turn to what?
9u to the power 8.
Good. So you see, we generally... Okay, so my advice is, Mikhail, people in class are looking. If something causing trouble, you can let it be equal to u, put it aside for now, and you can work separately. And you could use chain rule to connect the different rates of change at the end to get dy dx. Yes, this is calculus. So, Mikhail, our original equation was y in terms of x. So y is changing with respect to
X.
good. Y is changing with respect to x. So here what we needed to find dy dx. But you are seeing that we have du dx and we have dy du. And so what could I do there?
Multiply du dx by dy dx and the
No,
du
du dx by dy du what?
dy dx. Yes, sir. Sorry.
No, not dy dx, dy du what?
Du
Oh, yeah. What's gonna essentially cancel off?
du.
These are gonna cancel off, and that's gonna lead, that would be equivalent to dy dx.
Yeah.
And so du dx, we found that to be minus 1, and we found dy du to be what?
9u to the power 8.
So if you multiply that, what will you get?
Minus 9 u to the power 8.
Good, minus 9 u to the power 8. Good. But our original function was y in terms of what?
In terms of 7 minus x.
When I say in terms of asking you the variable,
Or x.
x. Yeah. And so what did we say u was again?
7 minus x.
Good. So I'm going to say minus 9, and instead of writing u, I'm going to write what?
7 minus x.
To what power?
Power 8.
Good. So let me go through the hack for this. It's essentially the same hack as last time. So, Mikkel, here's what we're going to do. Here's the hack. Here's the hack. We need to find the derivative of 7 minus x to the power 9. So what we could do is we could pre-multiply by the power. So that's gonna be we're gonna put a 9 where? We're gonna put a 9.
Outside the brackets in front.
Right? Then you're gonna differentiate the inside of the brackets. If you differentiate the inside of the bracket, what is that gonna be?
-1.
It's gonna be -1. I'm going to write back exactly what was in the bracket, but I'm gonna do what to the power.
Reduce it to 8.
Good.
Oh yes, I remember this. Yeah.
Let's do another one quickly using the hack method. Suppose you had to find the derivative of minus 5x plus 8 to the power of 3 over 2. So, Michael, apply the same hack. You're going to pre-multiply by?
3 over 2.
Yeah, 3 over 2.
Brackets, minus 5x. Minus 5, sorry. And then you write back. Yeah.
And I'm going to reduce the power by what?
1.
1. So 3 over 2 minus 1. And so that's going to be minus 15 all over 2. Minus 5x plus 8. 3 over 2 minus 1 is what?
3 over 2.
Nah.
Minus 3 over 2.
Nah.
3
over 2 minus 1 is what? Minus 1 is the same thing as minus 2 over 2.
Minus 1.
So what would that be?
A half.
A half. Yes, a half. So you could leave your answer like this is fine, or you could write your answer in third form. If you were to write your answer in third form, it'd be minus 15 over 2, what?
So you're breaking up there. I didn't hear what you say.
I'm breaking up?
I think it's my internet.
Okay, okay. Yeah. What third is to the power half? That's understood to be what?
Power half. What's third?
Yeah.
Maybe.
Those are indices. Something to the power half is what? Something to the power half is what, guys? Something to the power half is?
Square root in it.
Yes, the square root. So, Mikhail, something to the power half is the same thing as square root. So I can write this as minus 15 over 2. Square root
So
of what?
I get you off there when you say third. I thought you was asking for like what third represents that now.
Oh, no. Okay, cool. So the hack, you can use it, right? But if it's a standalone question, you have to use the full method to get your full marks. If it's being used in a product rule question, you're going to use the shortcut. Understand?
Yes, sir.
Okay. Let's do one more using the full method, and then we're going to do a bunch of questions, bunch of past paper questions. So, say we had y was equal to the square root of 9 plus x. Is that something that you would typically differentiate?
No, sir.
Nah. Now, before we could even do anything, what we need to do? Do you have any suggestions?
Change it.
Change square root to the power of a half.
Right, so I can write this as 9 plus x to the power of a half. And now it's in a form where we could recognize to use what? We have to use what here?
Chain rule. Or, yeah.
Chain rule. Who causing trouble in this?
The 9.
The 9 plus the x cause any trouble, guys? I'm asking that question, right? If you had y was equal to x to the power half, are you going to have any problem differentiating that?
No, sir.
No, you'd just say a half x to the power negative a half. You'd just multiply by a half and then minus 1 from the power. That would not cause no trouble. If you had something like if you had something like z is equal to u to the power half, that would be any trouble to differentiate dz du?
No, sir.
No,
No,
it'll
sir.
just be a half u to the power minus a half. That's not going to cause no trouble. But what is causing the problems here is the
9 plus x.
right. So, Mikkel, we could say that u is equal to what?
9 plus x.
Good. And if u is equal to 9 plus x, then the function now becomes y is equal to
U equals u to the power of a half.
good. So we've just broken down the problem into two very easily differentiable equations. Later, Renisha. And so let's find these separate rates of change here. So if we're differentiating this, it's going to be what over what?
Du over dx.
Right? Because we're differentiating the function u with respect to the variable x. So we'll say du dx. And if I differentiate this, what's that going to be?
1.
1. If you are confused, you're not seeing it, but x just means 1x. Right? If you differentiate 9, what would you get?
0.
0.
0, because it's a constant, right? And if I differentiate 1x, what's that going to turn to?
1.
1. So just 1. Over here, we have a function y changing in respect to
U.
right. So we'll say dy over,
Du.
and this is not hard to differentiate. Tell me, Mikkel, how would I differentiate that?
A half multiplied by 1. U. Right. Half minus 1, which is minus half.
Good. Do we want to find du dx or dy du though? Look at the original problem. What we wanted to find for initially.
Y.
Y with respect to
X.
right. So to find for dy dx, I'll have to use chain rule. So I have two different rates of change here. And now I need to connect them using the chain rule. So that's going to be du dx multiplied by
Dy du.
oh, before we leave tonight, I want to do some rates of change question with you guys. I love those questions. I love it. I love it. Those questions sweet, boy. Them questions sweet like Julie Mango. Not as sweet as Mrs. Mac vibes, dude. But you know what I mean? But yeah. So du dx is 1. What is dy du?
A half u to minus half.
Right. 1 by anything is what? So I have 1 by a half u to the minus half. What are we?
A half u minus 1 a half.
We're gonna leave it in terms of u,
No, we have to write back what u was.
right? What was u? What did we say u was?
9 plus x.
Now that's fine, eh? That's fine, but you could take things one step further. One step further. Let me show you what I mean. So this is fine, guys. This is fine. But if you are okay with indices, you could recognize that anytime you have a negative power, it will be positive if you send it to the, well, in this case, the denominator. Right. So this will effectively be 1 all over 2 by 9 plus x to the power of a half. If you are not seeing it, you have a half here being multiplied by 9 plus x to the power negative a half over 1. So you see, good. So if it's a negative power in the numerator, then if I send it to the denominator, it's going to be a
Positive power.
Positive.
positive power. So it's going to turn to 9 plus x to the power half. And we should recognize that something to the power of half is just
Square root.
square root. So I'll say 1 over 2 square root of 9 plus x. But you know, it's fine. If you want, you could leave it. You could leave it like this. This is not a problem. Everybody is okay with the question?
Yes,
Yes,
sir.
sir.
Okay. Everybody here only in the group chat and thing, right? Yeah or no?
Yes, sir.
Which one,
Yes,
sir?
sir.
The behave children one.
Yeah.
Yeah. I can't believe I had to do that shipping this, but make a behave children group chat because some people just can't control their stupidity. Shut up, boy.
So you're gonna crash out like Uncle Cool, you know.
Oh yeah. I'll crash out. When
You take your good fingers. Your mother take 9 months to make
I
to come and
don't
press 6, 7 in my chat.
hey, go in real go in wanted to shooting more day, boy. Hey, go in. Hey. Yeah, boy, but nah, it's be frustrating sometimes when people doing shippiness and trying to do something good. Right. In any civilization, you have people that serious and you have people that aren't serious and just they don't want to do anything productive with their life.
So I'll come back there.
Sorry, you see that thing going around that the maths paper was leaked before we do it?
I see that, but I don't think that gonna cause much of a difference, if I'm being honest. I don't think CXC gonna care.
Because I see a lot of people talk about it. Self soon as we come with the exam today, a bunch of people was like, yo, they say the maths paper was like 15 minutes before and CXC doing investigation, and I was like, so that means paper 1 and SBA.
Nah, I wouldn't bother with that. I just say focus on your work. Just keep focusing on your work.
Okay, sir, okay.
I don't do what I would that. I just have distraction. If something come of it, something come of it, right? But I don't think anything will happen. All right, let me tackle this. So, volume and revolution, sure. Could do volume and revolution. It's not a problem. So guys, Mikhail, you here? I think Mikhail is here. Anybody in class wanna help me with this question? Wanna run it through with me? Any volunteers wanna run it through?
Yeah, I could read it, but I can't guarantee I go understand, no.
That's no problem, Sarah.
Yes, sir.
Who's that? Virginia, that's you? Who said that? Nishana?
No.
Virginia. Megan?
Megan. Yeah.
Wait. Do I know you personally or because I
Nah,
hear
sir,
Megan?
you know me.
Oh, I don't know you, but thank you for coming to the live and thing. I hope it benefits you. Right? So
Help them.
when you read the question, this is to differentiate the following in respect to x. Now you're seeing that we have 2x squared plus 3 multiplied by sine 5x. So what rule you seeing immediately? What rule you seeing? Product rule. And how does the product rule look like? It looks like uv, so d dx of uv is equal to what?
V multiplied by du over dx plus u multiplied by dv over dx.
Can you identify what u and v is?
U is the function in the bracket, 2x squared plus 3, and v is sine 5x.
Did any of you guys have a hard time recognizing that this was product rule?
No, sir, because of the brackets.
No, sir.
Okay, good. So here what? Let's assign u and assign v one time. So I'm going to say u is equal to 2x squared plus 3. And I'm going to say v is equal to sine 5x. So let's differentiate u with respect to, come on, Megan. You're differentiating u with respect to what here?
X.
Right. And if I do that, what am I going to get?
4x.
Yeah, that'd be 4x. Because if I differentiate 3, what would I get?
0.
0, right? Virginia, you understand that?
Yes, sir. I remember you said that constants are 0 when differentiated. And I
And if you
think you
have
said the coefficient, right?
right. If you don't understand why, well, let me give you an example, right? These are equation, right? So y is equal to 5. As the x value changes, does the y value change?
No, sir. It remains constant.
And if it's constant, then the rate of change would be
0.
because it's not changing. It's not changing.
Yes, sir.
All right. So, Megan, how would I write this? I'd say I'm differentiating what with respect to what?
dv over dx.
Is this a standard case or do I have to use something different?
You have to use chain rule.
Good. But since it's within a bigger question, am I going to do the full thing?
Nope, too much time.
Then I had too much time, right? So here what? We're going to differentiate 5x. If you do that, we'll go.
5.
Come put 5 outside. If I differentiate sine, what I get?
Cos.
Right? Put cos. And I write back what was on the inside. If you want to put brackets, that's fine. I'll just come for 5x. You understand it or not?
Yeah, good.
All right, cool. And so now, if I want to find the derivative of 2x squared plus 3 by sine 5x, it is going to be equal to v by du dx. Remind me, what is v?
Sine 5x.
Right, sine 5x. What is du dx?
4x.
What is u?
2x squared plus 3.
What is dv dx?
5 cos 5x.
Cool. Let me explain a mistake students make, right? Some students would say 5x by 4x and they would say 20x squared. Are legal?
Nah.
Megan, is that legal?
That not legal, sir. That not legal. Not legal, sir.
But why? Well, you don't understand sine is a what? Sine is a what? That's what f.
The trig function.
It's a trig function. And Megan, what's just by looking at this, what are you plugging into the trig function?
5x.
Yeah, so 5x is within a function, so you can't mess with it. It's like literally in a function. So this actually means 4x sine 5x. Would you have made that mistake?
No, sir.
You say that. It's okay if you would have, but after today, it's not okay. Yeah.
Nah, sir, I good.
All right. Then you have 2x squared plus 3 by 5 cosine 5x. So what could we do there?
So we just put in the 2x squared by the 5 and leave the cos 5x the same. And then do the same for the 3.
Right? Because it distributes in.
So x.
And so 2x squared by 5 is going to be 10x squared. It's going to be 10x squared cosine 5x. And then
15.
yeah. You understand?
Yes, sir.
You know what would be real nice if CXC bring a question like this and then proceed to say for d dx whatever find the solutions and when it's set to 0 and you would have to solve it using trigonometric equations. That'll be bad. Yeah. You know what I mean or no?
Nah, sir. I don't know
It's
what you
like
mean at
proving a
all.
trig identity, sir.
All you know about trigonometric equations, all you?
Yes, sir.
No, sir, I didn't reach there.
I know, don't worry about it. Megan, you know about trigonometric equations?
Doesn't sound too familiar.
That's scary. That's really scary. Because trigonometry is a huge topic in hard maths. It's like gigantic. Right? Let me show you what I'm talking about. Like this. Solve the following equation giving your answer correct to one decimal place for 8 sine squared theta is equal to 5 minus 10 cosine theta where the angle is between 0 and 360 degrees. Never.
Oh no, so I've seen a question like that. I just never put a name to it. I just call it trigonometry in hard maths.
Well, it's trigonometric equations because what? You have one trig function equal to you have 8 sine squared theta, which is a trig function equal to
5 take away 10 cos theta.
right, which is another trig function. So hence we say trigonometric equations because trigs equal equation.
Yeah.
That's okay. If they do something like that, remember, right? Mark this down in our book, right? Maybe CXC could make it differentiate, and then they might ask it to find these solutions between a specific range. Could do that. Could. It isn't it isn't outside the scope. So CXC might make it differentiate something like this, and they might be like, hence solve for this one is equal to 0 between your range. But are you okay with this question, right?
Yes, sir.
Yes.
It's a easy 4 marks. Right? Easy 4 marks. Cool. Okay, what we're gonna do one more question like this, and then I'm gonna do 2 rates of change questions. And the only thing we'll have to look at in differentiation again is stationary points. Maximum or minimum nature of stationary points. That's all.
So and that with second derivative, I think.
Yeah, that's what second derivative. So if the second derivative is a negative, is a maximum. If the second derivative is positive, is a minimum. He said, in Mikhail, if you ever wondered why in maths you just learn that if it's positive is a minimum, that is why. Because the second derivative is positive. Yeah, you learn a lot of things in maths, and when you do hard maths, you realize it. Yeah, you have your mic muted, and I can't really see what's going on there.
Oh, this is that same thing, sir.
Okay, nice. I see this
Yeah.
really great at maths.
Hard maths.
Hard maths. All right. Let me do another question like this.
So in Shiba Boys, I used to get put in detention by my maths teacher because I used to do real bad now. So I had to grind and
Who's that?
get good at it. See that?
Who's your hard maths teacher in Shiva Boys?
Miss Priya and then Miss Umati.
What? Oh, that
Yeah,
real
you
funny.
know, the first name I call, I used to really get in trouble with she.
That real funny boy. Points of inflection does not come, but I still will. You can never be too careful with CXC. For those of you guys that don't know, let me show you what a point of inflection is. So consider I have a cubic here. So you see how in this region we have a maximum and in this region we have a minimum? Let's see in that or no?
Yes, sir.
Right. So over here, the second derivative, d2y dx squared, will be less than 0. Over here, d2y dx squared will be more than 0. But you know how like you have a quote-unquote turning point? Well, inflection kind of similar. So you see at this point, the second derivative would be equal to what?
0.
0. And this is called the point of inflection. Point of inflection. Right?
So I remember that as the at a stationary point, dy dx is equal to 0.
Are we talking about two different things, you know? Mikhail, we talking about two different things, you know?
Oh, okay.
You talking about stationary points. I talking about point of inflection. Yeah.
I forget that there's two different things there. My bad.
Mm-hmm. That's two different things. Right. Because I was talking about d2y dx squared equal to 0. You was talking about dy dx is equal to 0. You know what I mean? All right, let me tackle this question now, guys. Olio. What we had to use here? You look at it and tell me, we had to use here. We had to use there.
Chain rule.
Yeah, you had to use chain rule, but what primarily? Primarily what?
The
Product
product.
rule.
The product, right? What is u and what is v?
U is 5x plus 3.
And sin x is?
V.
Right. And if you're dealing with the product rule, it's going to be d dx uv, that's going to be equal to v du dx. What?
Plus U dv over dx.
Right. So here what, right? We had now so u go be equal to 5x plus 3 to the power 3. And what would v be equal to, Mikhail?
V will be equal to sin x.
Yeah. Now, Mikhail, seeing that this question over here is inside of a bigger question, are we going to do full on are we going to do full on chain rule?
No, so you use the hack.
Yeah, you're going to use the hack, right? So you're going to tell me how the hack does work.
So you multiply 3 in front of the bracket. You get the derivative, which is 5. And then you write back the original.
And
And
you do
then
what
you
with the
put
power.
the power 2.
Right. So 3 by 5 is
15.
cool. Easy peasy lemon squeezy. Bam. Add maths is vibes. Then this is going to be dvdx. What is dvdx going to be?
Cos x.
Cosine x. Bam. So if you want to find the answer, all you understand when I say add maths is easier than maths.
It's just one set of rules you have to follow and just interpret the question and apply those rules.
Yeah,
Formula.
none of that. 75 grams of flour and this gram of that.
So I get a
None of that.
question so wrong. I divide that by 20.
No,
Oh.
same. I on the same level with Mikael. I did the same thing and I was like, something ain't added up here, but I just got flow with it. And I
So
move on to the question.
when I divide by 20, I just approximate up. So one was like 8.75.
Oh no.
I
You can't
approximate up.
approximate. You cannot approximate up, Michael. Where you getting flour from a magical hat? No
Okay,
boy.
no,
You know.
no.
Yeah,
When
you
you're
can't
Well,
supposed
wrong.
to
I
divide
wasn't
by
doing
25
that. I
now,
was
so but I was
magicking
like,
up words.
Oh.
I
And
was
like
just
something,
magicking numbers. That was all I was doing. It was magic and math. Simple.
you
Magics.
really had to think for that one, boy. That's why I see your question. Because think about this, right? If you're making a pack, right, and I have 12 in a pack, could you move like earlier? I ever tell you about the time I buy a Dixie and I only get 2 Dixie.
what do you mean? Like
Only
the
two
pack with the peanut butter on it?
biscuits.
Yeah, it's a 6. I get 2 in it, dog.
That's
How?
rubbish. That's free. I would ask back for my money.
I ask back for my money, boy. But Mikhail, here you are saying, right? If you're making a pack and I have 12 in a pack, you feel like you could sell a pack if you don't have 12 in it?
No, sir.
No, so the first thing you're supposed to do is figure out how much flour you go take to make one pack and divide that by the total amount of flour you have. Because obviously you can't make if you don't have a full pack. So supposed to do that. Once you figure out how much packs you can make, Then like you multiply that by the amount of flour you use to make one pack and see how much flour you use. And once you have how much flour you use, you can take that away from the total amount you had to find the remainder. Simple.
Yeah.
Yeah.
Sorry, you explained it a lot. If you had just come in the exam and whispered, but I would have been so nice for me.
Sarah,
I, I was
as soon as
I
I didn't see circle theorems, I feel sorry for you, girl. I feel sorry for you. She was ready. You had guns blazing for circle theorem. You had
I
guns
didn't
blazing
know.
for circle
So I
theorem.
opened the paper. I was like, okay, switch. I looked at the paper. I was like, where the heck is factorization, circle theorem, simultaneous
Boy, they
equation,
do a little wicked, boy. They do a little
persistence?
wicked, boy. I know if circle theorem had come on, then I mash up that,
Sure.
though. Mash
I,
up that.
I said this to everybody. If I could catch the man who makes CXC, man, he go fight. Cause what was
So
that?
when Springer say they fire the man with measurements. He doesn't mean measurements question.
Oh
Because
yeah,
it's
yeah, yeah.
measurements he doesn't.
Because here what, right? If you're using AI, I don't saying earlier, quote unquote. If you ask AI to make a paper for you, AI is not gonna make any like graphical questions really. Like any complex questions with parameterization, they're gonna struggle to make those type of questions. So I don't know. I don't know.
Unless you
To be
add,
honest,
yeah.
All right, let
to
me
be
continue.
honest,
Yeah?
this year is like they just decided, you know what? Enough of them past papers thing. Let's just bring a whole new everything and see how they go with it. Like
No.
somebody in the chat say that it was we was the experimenting set for the next set. And I
Probably,
agree with
probably.
them at this point. I agree. But anyway, so I go clock out now.
All right,
Big
Sarah.
up to
Big
you,
up yourself. Thank you for the
math
support.
people.
Big up
Thank
yourself.
you.
All right.
Big up to you, math people. Y'all got this. Keep vibing. Remember, math vibes to the world. Okay?
Math vibes to the
Bye,
world.
guys.
That what we saying. Big up yourself, Sarah. Right?
Bye.
Right. So let me continue, right, Mikhail? Easy thing, right? Easy thing. We know what V and we know tell me, how we moving? We know everything here. Where's V?
Sin X.
V is sin X. What is du dx?
DDX is 15 brackets 5x plus 3 to the power 2.
Right. And then
Plus
plus
U is 5x plus 3 to the power, well, cubed.
now. Or cube, you see. I thought you said 2, but it's 3.
No,
Right? What is the VDX?
dvdx cos x.
Now, when I look at this question, I seeing that we could potentially pull out something. Are you seeing that or not?
Yes, sir, the 5x plus 3.
X plus 3.
Yeah.
I could pull out 5x plus 3 to what power though?
2.
Power 2. If I do that, and I pull it out from here, what will I write in the brackets?
15.
15.
15 what?
Sin X.
15 sin x. Yeah, 15 sin x. Again, I'll say this. Some students are going to go in the exam and say 15x. That legal?
No, sir.
No, that is not legal because this is a what is that?
Function.
As a function. And
Three.
and x is inside the function. If x is inside the function, you can't mess with it. Alright, so that's 15 sin x. And if I pull out 5x plus 3 squared from this,
You'll just have 5x plus 3 cosine x.
yeah, 5x plus 3 cosine x. Yeah, are you good?
Yes, sir.
Yes, sir.
Okay. If you are confused, let me explain something. We pull out 5x plus 3 squared. Now 5x plus 3 cubed means 5x plus 3 by 5x plus 3 by 5x plus 3 because it's 5x plus 3 cubed. So if I pull out 2 out of the 3, what will remain?
1.
1 5x plus 3. Yeah. So are you okay with product rule, quotient rule, chain rule and thing?
Yes, sir.
Yes, sir.
Right. So here what? Let me tackle 2 rates. I change question and we'll call it a night. Because my neck hurts me. My neck hurts me, boy. And
Yeah.
I didn't like the turnout, boy. A real shame, boy. These people are not serious. These people are not serious, boy. It's a
So, what was
lucky.
the max amount of viewers you had on TikTok and YouTube?
TikTok was like 350 or something. and YouTube was like 1,000.
No. I mean for like this class.
About AdMaths.
Yeah.
I never really do AdMaths before, so I can't say. This is the first time I do AdMaths live.
Oh,
Yeah. AdMaths don't get the love it deserves, bro. AdMaths has peaked. Right. Let me look at rates of change. Now, when I talk about rates of change, we will have different rates of change, right? Different rates of change. And when you're dealing with different rates of change and you want to connect them, how do you connect different rates of change? Righty?
Chain rule.
Chain rule, yes. Yes, you use chain rule if you want to connect different rates of change. Let me put it in red. This could sound controversial, but I find like if you had to teach with a textbook, you don't really know your work. Low key. But like, okay, when I started teaching, I had to teach with a textbook because I really wasn't well versed. But like now, I really need a textbook to teach. You know, like how some of them pundits sounding on Imam and them just be reading from the top of their head?
Yeah.
Yeah, like that's flow state, you know what I mean? That's flow state. If you know your thing, you could just do the thing without a textbook or anything. So
That's
here, well, let me pick a question now. Pick a question. Rates of change don't come all the time. I see one in 2015 here. Oh yeah, I feel like our rates of change might come this year, no? I feel like our rates of change might come. I feel like I feel like it might be our first principle, and our rates of change. With how funny they're moving. I don't know. Cool. So Mikkel, get our read from her.
a spherical balloon of volume 4/3 pi r cubed is being filled with air at the rate of 200 centimeters cubed. Oh no, I said that wrong. 200 centimeters cube per second. Calculate in terms of pi the rate at which a radius is increasing when the radius of the balloon is 10 centimeters.
Oh, when you read these types of questions, they sound scary, yeah, boy.
So it looks scary.
It
Not
looks
really.
scary. Hey, what? After today, oh, you're never gonna get a question on this wrong again. Never. I can't show you how the hacks just be moving.
All right,
So
so
the first thing they give me is volume, right? They give me a formula for volume. And they say volume is equal to pi. What's saying, boy? 4/3 pi r cubed. That's what they give me. Now, I want to ask a little question, right? Answer this, Summer. Answer this. This formula tells you how the volume changes with respect to the what?
The radius.
radius.
Yes, the radius. The radius. And if I put in a different value for r, I'll get a different for my volume.
Oh, yes, sir.
Yeah. So volume is changing with respect to the
Radius.
right. Is pi r unknown?
No. It's just a
No.
constant thing.
Yeah, Megan. I know a lot of students. Some students go be like, they go see the pi, right? And they go think it's a variable. Megan, you would do that or not?
So I'm not really sure.
That's okay. That's okay. But no, you know that pi is a what? Pi is a what? Is a variable or a constant?
Constant.
Right? If you're confused, right? Maybe you're saying that just because you're not seeing a number, right? But pi, isn't pi 3.1 whatever?
Yeah.
Yeah, that's what pi is, right? That's what pi is. That's pi. So it's really pi is really a what? Pi is really
A
a what?
constant
A constant.
changes.
An irrational
Yeah.
number. It's really an irrational number. It does not change. It's a constant. So don't go and think that pi is a variable, just because it's looking like a letter, a Greek letter or something. I don't know. Is that a Roman or a Greek? I don't know. Anyways, so here what? Potentially, potentially, right, I could differentiate this with respect to what?
R.
Or
Megan, what could I potentially differentiate that as? I would say what over what?
dv over dr.
Yeah, so hold that thought, right? Hold that thought, Talia. Hold that thought. Hold that thought, right? Maybe we might need to find dvdr. Maybe. And the saying is being filled with air at the rate of, let me underline this one time. Let's see, they're talking about rate, right? Rate. 99% of the time, if we're talking about a rate, we're talking about something changing with respect to what? Rate. Something with respect to what?
time?
Time. So understand what happening here. It's being filled at a rate of 200 cm cube per second. So cm cube, what does cm cube talk about? Cm cube is what?
Volume.
Volume. And s minus 1, they're really talking about what?
Oh, time
1
per
over
second.
So let me show you some badness, right? Let me show you some badness. You know what I mean? That's just telling you how the volume is changing with respect to the
Time.
yeah. Yep. So dvdt is 200. Yeah. I'll leave me on the units for now, right? But just know it's centimeter cube per second. Mikhail, you see how I figure out that just from the units?
Yes, sir.
Yeah, so Mikhail, when you see cm cube, what are you thinking about?
Volume.
When you see s minus 1, what are you thinking about?
Time. Seconds.
Right. So Mikhail, the volume is changing at a rate of 200 cm cube per.
Second.
So every second that elapses, the volume is going to increase by.
200.
Right. So this is telling us the rate at which the volume is increasing with respect to. Mikhail,
Time.
with respect to time. So I need you all to be moving like this with the mathematical badness, right? And anytime you see units, please write the rates are changed in symbolic notation. So centimeter cube per second means dvdt. Okay. Watch how easy this is going to be, right? So, Mikhail, they want me to calculate in terms of pi the rate at what?
The radius is increasing.
So, anytime we're talking about rate, we understand that one of the units is what? Rate. Rate is what?
Radius.
Well, yeah, but like rates are given with respect to what? Rates.
Time.
Time. So when I read this line, I know that I need to find dr over.
dt.
Yeah, dr dt. This is what I'm trying to find. When the radius of the balloon is 10 centimeter cube. So they're telling me the radius is what?
10 centimeters.
Right. And they want me to find the rate at which the radius is increasing. So dr dt. Watch how bad this is, right? Watch how bad. So, and they give me the formula for volume.
Yes,
Yes,
sir.
sir.
Right. What else we could find from that?
Volume, since again.
Nah, that's not what I mean.
The rate at which volume is changing.
With respect to the
Time.
Radius.
no.
Radius.
Hey, Olio, we're not seeing time here. Volume is changing with respect to what variable?
Oh, radius.
Radius.
Right. So from this, we could potentially find what, Megan?
dv over dr.
Good. Because and if I put in different values for r, what's gonna change?
The volume.
Exactly. So dvdr. This is what we're trying to find. It's real simple, you know. When let's see it, it will be like, oh, and what they give me?
They give you the rate.
The rate at which the volume is changing with respect to the
Time.
Olio, watch badness. Watch mathematical badness. We need to find what again?
dv over dr.
Nah.
over dt.
Or dr over dt.
Right, because they said find the rate at which the radius is increasing. So dr dt is what they want me to find. Also, forget about everything else. So let me show you how the badness go. Forget about everything else. If you want to get back dr dt, right? And you know you're going to use chain rule, you'll multiply two different rates of change. Then you know for sure that what must come on top, what you must have on top.
d.
dr.
dr.
You must have dr. You must have dr. And we must have any bottom here.
dt.
Yeah,
And whatever you have here and here, it should be
The same to be
same.
cancelled.
the same. So you go cancel. No, let me look at the information we're dealing with, right? This is the time where everything will click. Let me ask you a question, right? Are you seeing anything over t, dt?
The rate.
Are you seeing, look at the information we laid out, right? Are you seeing
dv.
anything over dt?
dv.
Yeah, the rate.
dv. I see in dv. So watch badness, watch badness. Just by figuring that out, we think also how to come over here.
dv.
dv.
Yeah. Could I find dr over dv?
I guess.
Yeah. Now this is not one of the most straightforward questions, right? But look at something. Look at this and look at this. Look at this and look at this. What's the only difference?
Replacement.
One is the what of each. What is the one of what is one is the what of the other one?
Reciprocal.
Reciprocal. So all I had to do is find my answer here and just do what with it?
Flip it.
Flip it. That is all. That is all. If I tell you dr is 5, what do you think dr over dv go be by?
1 over 5.
That is all. That is all. So let me run over the hack for these types of questions one more time, right? One more time. Number one, if they give you a formula for volume, you put it to the side and you ask yourself, what rates of change could I find for this? What rates of change you can find for this?
dv
The
over
rate at
dr.
which r is
dvdr. You can find for dvdr. Cool. Then you're going to look at any pieces of information they give you. They tell you 200 centimeter cube per second. What does that involve?
Volume and time.
volume and time.
Right. So that'll be what over what?
dv over
Over
dt.
Right, dv over dt. And then you want to look lastly what you're trying to find for. What are we trying to find for?
The rate at which the radius is increasing.
Right. So anytime you see rate, please note you're dealing with time. And they said radius. So you're dealing with dr over dt. So this is what you are trying to find. dr over dt. So immediately you should be thinking, what two things I can multiply together, boy? Well, if I want to get dr, what had to come over here?
dr.
How to
dr.
put dr? What coming over here?
dt.
And then we need to figure out what else we're going to put here and here. But it must be the same, and it must be the same.
Yeah.
Must be the same. And so then you zoom out and you see, okay, we had to get something over dt. Is there any pieces of information given? Were there anything over dt?
Volume dv dt. Well,
dv over dt. So automatically you're going to put dv over here. If you put dv over here, what had to come over here?
dv as well.
Right. Right. It's a systematic approach. It's something you can figure this out. Again, I feel like this is easy marks, once you understand the trick. So Mikkel, run one more time, Mikkel, one more time. We are trying to find drdt, yeah? drdt, right? You know you have connected rates of change here, so you gotta multiply. So tell me, Mikkel, what will have to come over here?
dr.
dr have to come over here. What have to come over here?
dt.
dt. And so now you're gonna zoom out. Did they give us any pieces of information? with something over dt.
Yeah, dv dt.
dv. So we're gonna come over here.
dv
And if dv over there, where dv are to be as well?
under dr.
Bam, bam, bam. And that's simple all here. Mikhail, it's easy, right?
Yes, sir.
Yeah. More questions, the better you see it. But this is the hack for all these types of questions. Next thing, you're seeing dr over dv. How are you gonna get that? Isn't that just the reciprocal of dv over dr?
Yes, sir.
Yeah. And in the question, they said when the radius of the balloon is.
Increasing.
Nah. Read back the question. When the radius of the balloon is
10 centimeters.
10 centimeters. So here what we're gonna do, right, guys? Here what? Let's find for dvdr. What would dvdr be?
3 by 4/3 by pi
R to what power?
squared.
If you're confused, right? So Virginia or
Yes.
Megan, if you guys are confused at all, if any of you all are confused at all, we are differentiating the volume with respect to the radius. The radius is to the power of 3. So you're going to pre-multiply. So you're going to multiply everything by 3, right? So do you guys understand how I got 3 by 4 by 3?
Yes, sir. And then n minus 1.
Okay, take away 1 from the power. That's how I get 2.
Yes, sir.
So 3 by 4 over 3 is going to give us what? The 3 and 3 are going to cancel off to give you what?
4 pi r squared.
Bam. Now in the question, they said when the radius is
10 centimeters.
Yeah, 10 centimeters. That's what they say, right? So where do you think I could plug into this?
10.
10. Because they said when the radius of the balloon is
10 centimeters.
right. So that's going to be 4 pi 10 squared. And so what are going to work out to be? Hey, they said in terms of pi. So you're not gonna plug pi and take in your calculator. No. In terms of pi. So just work out the 4 by the 10 squared. What that will be?
400.
400.
400 pi. And we must not forget, this what we found is actually dvdr. But in our connected rates of change question, we need to know what is.
What dv is.
Alright, so if dvdr is 400 pi, what do you suppose drdv is?
1 over 400 pi.
If you're not seeing it, I'll explain something. 400 pi is the same thing as 400 pi over what?
1.
1. So if I flip this side, I will flip this side as well. So it's going to be dr over dv is equal to 1 over 400 pi. Yeah. Are you understand?
Yes, sir.
Okay, good. And so now where can I plug that in?
dr dv.
dt.
I plug it in over here. So 1 over 400 pi. And somebody tell me, what was dv dt?
200.
200.
So what's going to happen here?
You could reduce 200.
200. 1 over 200 pi.
Yeah.
So this is going to tell us the rate at which the radius is increasing with respect to
Time.
time. So radius is measured in what units?
Centimeter.
Yeah, centimeters. If you look at the units for length in this question, it was centimeters they was using, right? Centimeters. Okay, centimeters. So radius is centimeters. And time is what?
Seconds.
So that'll be centimeters per second. You could write it like that. Or you could write it as centimeter by S what?
To the
minus
power
1.
this one.
Yeah. Now, are you ready for me to blow your mind?
Yes, sir. I'm ready.
check this out. Check this out. What were the units for dr, dv, boy? Well, radius is centimeters, and volume is what?
Centimeters cubed.
Right, watch this, right? So all you understand that this over here represents dr, dv, right?
Yes, sir.
All right. cm over centimeter cube would be what?
Centimeter squared.
Centimeters.
1 over centimeter squared. Right, because 1 of the centimeters on top will cancel off with 1 on the bottom.
Yes, sir.
And then dv dt, what would that be? Well, volume is centimeter cube, and time is seconds. Now, let's see what would happen if I multiply 1 over cm squared by cm cube over a second. What's going to happen there, guys?
Oh, you just end up with
Centimeter.
per second.
Right,
That's
centimeter
Squared.
per second. Bam. Yeah. Somebody asked, how did I get a 1 over 200 pi? Let me explain, right? So you have 1 over 400 pi here. And then you're multiplying that by 200 over 1. 200 into 200 is 1. And 200 into 400 is... We make a mistake. It supposed to be 1 over 2 pi. Well, let's see. That's on.
Oh, yeah. Oh, sorry.
Yeah. Thank you for that. Whoever you are, big up yourself. Right? You see how you gotta be real careful, all yeah?
Yes, sir. Oh my gosh.
So 1 into 200 is 1. 200 into 400 is 2. Right? 1 over 2 pi cm per second. Badness. So, Mikhail, you think you have the formula unlocked for these types of questions?
Yes, sir. Just had to practice it and I'll get it down.
For sure. Well, here what? Before I leave, I do one more question like that. One more question. Okay, here's a question. Let me mash up this question now. Let me mash up this question.
Okay, sir. Okay.
So are they done on the motions, right? Here what? Done on the motion. So Mikhail, get the question I'll read for me.
Water is poured into a cylindrical container of radius 15 centimeter. The height of the water increases at a rate of 2 centimeters per second. Given that the formula for the volume of a cylinder is pi r squared by height, determine the rate of increase of the volume of water in the container in terms of pi.
Bet. So, hey, this question really easy, Mikhail. Real light work. Here what? Let me examine the question, huh? So the first thing they're telling me is that they tell me what the radius is. What is the radius?
15 centimeter.
Put that on one time, don't stick. R is equal to 15 centimeters. And then they say the height of the water increases at a rate of
2 centimeter per second.
right. The what? Wait, the what? The what? The what?
The height.
The height. So could we represent that as a rate of change?
Yeah, dH over dt.
Yeah, dH over dt. All you understand that?
Yes, sir.
Okay, I hope all you understand that now because what? Centimeters is measuring height and s minus 1 is measuring time. So dH dt. dH dt. Do you guys understand this?
Yes, sir. Yes, sir.
Okay, good. And then they say, given that the formula for the volume of a cylinder is pi r squared h. So immediately, what am I gonna come on right?
dV over dr.
Wait, take your time. I'm gonna write V is equal to pi r squared h.
Yeah.
You gotta be a bit more cautious with this one. Because this one, how much parameters are there?
Oh, there's 3.
No, not true. Pi is now unknown, eh? Pi is now unknown. You know pi. Pi is a constant. Pi is a constant. In case you're thinking that pi is a constant. So
I was thinking about volume, radius, and height.
Oh, well, I guess, yeah, that's valid. That's valid. That's valid. That's valid. You have three parameters: volume, radius, and height. What are the inputs to? The inputs.
Oh, well, radius is 15. So 2?
Hmm. Oh, you see how she just mentioned that? Mikhail, you see how she say radius was 15?
Yes, sir.
Mikhail, if radius is 15, truth be told, was he only one unknown boy?
Height.
Height. Height. So V is really just, what is 15 squared?
Um,
What's 15 squared?
225.
225.
Hope you guys not confused, eh? Here what I'm saying. We know that the volume of a cylinder is pi r squared h. Pi r squared h. If you have a cylinder, Alia, make this make sense, right? Alia, think a lot of students just learn concepts and never really understand them. I don't want Alia for here to do that. Let me explain something, right? Imagine you have a cylindrical container and you're pouring water into this, right? Will the radius ever change, Alia?
No, sir.
Sir?
No, sir.
No. No, the radius won't change. What will change though? What will change? What will
The
change
height.
as time passes?
Yeah.
The height of the water.
The
Oh,
height of the water. Watch. So this could be like one snapshot in time. Are you understanding or not?
yes, I'm understanding.
So like this could be for one snapshot in time. If some more time passes by, you can reach over here. But will the radius ever change?
No, sir, it remains
No,
constant.
sir.
No, it remains constant. So you see, all you had to think through these questions logically. So the only thing that's changing here is really the what?
Height.
Height.
So if that is the case, what could come up with? What rates of change I could come up with here?
dV over dH.
E over
Good.
D.
I could come up with
Yeah.
dV over dH. Let me find out one time now. Let me not stick. What would dV dH be?
225 pi
Pi.
h.
No,
No,
just
yeah.
225.
Yeah.
If you're confused, right? See, I ask you was y is equal to 5x. If you differentiate that, what would you get?
5.
5. So if I ask you what dV dH is, wouldn't that just be 225 pi?
Yes, sir.
Yeah.
So I cannot
Virginia,
cook right now. My bad.
you
Yes,
can.
sir.
You mean you cannot cook in? You cannot cook in?
With me?
A
No,
little bit
no.
of the both, sir.
I think like everybody here cooking, right? Big up all yourself. So
Yes, sir.
dV dH is equal to 225 pi, right? So we handle the formula they gave us, right? We know we handle the formula they gave us, right? And let's look at what they want us to find now. They want us to find the rate of increase of volume. Again, earlier, anytime they see rate, you know they're talking about what? For sure.
Time.
Rate is time. We see in time and we see in volume. So what would the rates of change for that look like? It could be what over what?
dV over dt.
dV
Oh,
over dt. Because the time wouldn't earlier. Think about this logically, right? If you say dt over dv, right, then you are saying the time changing because of volume.
oh, nah.
Okay, that making sense?
Nah.
No, that don't making sense. Time
So
can't change.
is
Time
that
can't change.
why time is always on the x-axis?
Say that again?
Is that why time is always on the x-axis?
Yeah, you can think about it like that.
Yeah.
Yeah. That's actually a really good reason, you know. That's actually a really good reason because if I were to plot this right, then dv would be on the y-axis and time would be on the x-axis. You would never have an instance where it's dt dv or something like that.
Oh,
That's a
okay.
brilliant observation. And
Thanks.
I never think about that. But when you say it, it makes sense. Right?
Thank
So
you.
do you guys recognize where to find for dv dt or no?
Well, I recognize it now.
Well, here again, read the line from Megan. Read it again.
Rate of increase of the volume of water.
So what changed in there?
The volume.
With respect to?
Oh no, the time. Oh,
No,
the
no, no.
volume respect to time. Yeah.
Right.
The volume.
Again, Megan, are you going to say that time changes because of volume?
No.
No, that don't make sense. If that was the case, when I fill up this water bottle, I will change the whole time continuum. I will break the time continuum. Yeah, that don't make sense.
Yeah.
Right? The volume changes with respect to time. So, do you understand that we have to find for dV over dt?
Yes, sir.
Right. Time is always in the denominator, right? Good. So here what we're going to do, right, Megan? I'm going to put on dV dt, right? I'm going to write dV dt. That's what I'm going to do. And I know I'll have to multiply two different rates of change. I will have to do that. So tell me, Megan, what would go here for sure?
dV
What would go here for sure?
dt.
All right, let me look at some mathematical badness, right? When I zoom out of the screen, I want to hunt for something for the missing variable, right? Hunt. The hunt is on. What are you looking like?
dH over dt.
Yes, because just see any dv over dh here. You're seeing that, right?
Oh yeah, I know saying that.
That's the hint. That's the hint, Megan. That's the hint I'm trying to say. That's the hint I'm trying to say. You know what I mean? Yeah, so it had to be dh. And obviously, if dh over here, it got to be here as well. For it to cancel off, right?
Yeah.
Good. Don't we know what dvdh is?
Yeah.
What's dvdh?
220.
Right, dvdh is 225 pi. What is dht?
2.
2. What's 225 by 2?
450.
Your answer is 450 pi. But you need to put the units, right? It's volume with respect to time. So volume is going to have what dimensions? What units?
CMQ.
Right? And time is per second. You can write it like that. Or you could say cm cube what?
Per second. S take away 1. Well, to the power negative 1.
Badness. Mikhail, how you feeling about these sets of questions, boy?
Yeah, much easier than the way that teacher teach you this.
Oh, you just look at the question from a logical standpoint, right?
Yes,
So
sir.
you're looking at the information they give you. Put all of that down. Look at any rates they give you. See how they give us centimeter s minus 1. That means it's dh over dt because they're talking about height, right? The height. So immediately I go and write dh dt is 2. I know that dh dt is 2. Good. Then they give me a formula for volume. Volume is pi r squared h. So v is equal to pi r squared h. But think about it. Mikhail, if you have a cylindrical container, does the radius change? Watch this.
No, sir.
If I pour water into this, is the radius gonna change?
No, sir.
What's the only thing that's gonna change?
The height of the liquid.
Exactly. So the only thing that's changing here is the volume with respect to the
Time.
height.
No, height. Sorry. Yeah.
That's okay. Height, right? Nice. So here it is now. You had the HDT and you have the VDH, right? You had that sorted. Now you look at what they were to find. They were to find the rate of increase of volume. So immediately we know that is dVdt. Right. Forget about everything. Write down your dVdt. You go put dV, you're gonna put dV over here and you're gonna put dt over here. Now you're looking for the missing variable. Bam. You zoom out, dVdh, bam, dh. dVdh, we have that, bam, 225 pi. dHdt, 2, bam, the answer. Badness. Easy max. These questions is easy max. Yeah. 5 easy marks. So we cover a good bit of differentiation today. How the final was? It's good?
Really good.
Yes, sir.
Nice.
Yes.
So guys, see you later tomorrow.
I really feel like students miss out on a big opportunity to learn hard maths, or like they
That's why I
find what is
saying.
more early.
That's why I saying, right? Yeah, maths actually kind of cool when you think about it. Like I sure, like okay, when I showed this, I sure didn't think about it, right? I sure didn't think about like think about it now. If you have a cylinder, what is the only thing that will change in the cylinder?
The
Height of
height
the liquid.
of
The
volume.
height. The height. The height. The height will change as the volume increases. That makes sense, right?
Yes, sir.
Yeah. Oh, but when you think of maths and this is on a paper, you don't make the connection, but try to make the connection. But that's it for today. Tomorrow we will look at stationary points, and the nature of turning points. Right?
Yes,
Yeah,
sir.
guys.
Okay, so
I don't know what that is, but I'm ready.
Virginia trolling, boy. I feel like Virginia trolling.
Megan can confirm for me. She's in my school. She's my friend. I invited her. Sir.
Bro, so she really informed for.
Yeah,
Hey, boy.
I
That's
so
invited
she
crazy.
better than me when I was in Form 4.
Hey, boy.
Boy.
Sir, I showed Megan Matt's vibes, I was following you since Christmas. I sharing
Oh,
it, sir.
oh.
She helped me out.
Yeah, boy. Too much people don't know about math vibes, boy. It's sad, boy. But hey, you see that? It's at 28,000 likes, boy. Wait, boy. 28,000 likes on that post somebody make It's crazy.
Uh-huh. I see
Yeah.
the video where you do talking about the maths paper had like 6K views.
Yeah, boy. And another video on YouTube had 27,000 views.
Yeah.
Yeah, boy. Are we going? We
So
going?
the night before with all the lives, you was the second highest. You had the second highest view count. Current Springer was the first, and you was the second.
But I only doing this thing for a short period of time, I really
Yeah.
young too. Yeah. How these men doing this for like what? I don't even know how long. But I doing this for like less than 5 years. When I was in secondary school. So like things starting to build now. Don't worry, everybody gonna know about me. Future of the Caribbean dog. Math vibes is the future.
Yes, sir.
But
Yes.
but yeah, guys.